Today we are going to be looking at what affects the performance of the CPU. So first of all, we need to understand what is the CPU. So CPU stands for Central Processing Unit. And that's a common mistake that people make, that because people often think that the C stands for computer, but we know that it doesn't. It stands for central. And they can ask that on your exam. They might sometimes get you to fill in the gaps and the blanks, things like that. And you don't want to fill in one of those wrong because it's a very easy mark that you don't want to lose. Okay, so in terms of what the CPU actually does, well, it actually does billions of what we call the fetch, decode, execute cycle. And we're going to go into more detail about that in just a moment. Now, in terms of where these instructions come from, they can come from input devices like your mouse or your keyboard, for example, or it could be program instructions, so the open programs that you've currently got running. How do the CPU and RAM work together? Now, I've put in brackets there main memory because RAM is main memory, and you can use those terms interchangeably in your exam. It doesn't matter. You wouldn't lose the mark for using RAM rather than main memory, and vice versa. So the CPU will fetch the instructions from RAM. That's the proper word for it because that's the F in the FDE cycle. It will then bring that instruction back to the CPU. The CPU will then decode it, which is obviously the D in FDE. Once it knows what the instruction is, it will then execute that instruction. And that doesn't mean to execute it, not that kind of execution, to carry out that instruction. Okay, and that is the FDE cycle, which it will just keep on repeating billions of times in 1 second. Now, when it comes to the performance of the CPU and how well it carries out those FDE cycles every second, the easy way to remember it are the 3 C's. And the first one is the clock speed, which we're going to talk about in a moment. Next one is cores. And finally, it's the cache. So your clock speed is measured in what we call hertz, but common up-to-date CPUs, you won't often see just hertz. You're going to be looking at something like gigahertz. So a typical clock speed would be something like this, 3.5 gigahertz. Okay, so the G being the giga, but we've still got hertz in there. Now, what that actually means is 3.5 billion instructions per second. Per second is actually really important, okay? So the higher that clock speed, if that was a higher number, you would be able to carry out more FDE cycles per second. Okay, the next thing that affects the performance are the cores. So a CPU can have multiple cores, and if you were explaining why that might affect the performance, you could say that each core works independently. So let's have a look at some examples combining what we know about clock speed now and the cores. So here's an example of a CPU, 3.2 gigahertz dual core. Okay, so when we see the word dual, it means it's got 2 cores. Okay, so we've got 3.2 gigahertz, which we know is 3.2 billion, but then because it's dual core, it can do up to 2 times that amount. So 3.2 times by 2 or multiplied by 2 will give you 6.4 billion instructions per second. Let's have a look at one more example. So here's 3.5 gigahertz quad core. So we're going to do 3.5 multiplied by 4 this time. And you can think of quad being like a quad bike with 4 wheels. It's an easy way to remember it. So 3.5 times by 4 will give you 14 billion instructions per second. And the final thing that will affect the performance of the CPU is the cache. So cache holds frequently used instructions, and it's located on the CPU. It has much faster access to cache than main memory. Too much cache could be detrimental to the overall performance. So some cache memory is good because you do have faster access to cache than main memory, and that will speed up the performance of the CPU. So just to finish this session, I wanted to just put some example questions that you can have a little practice of. So it's probably a good idea if you want to pause the video now. The best way to revise with these kind of questions is try and not rewind the video. Try and not look back at any notes inside your book that you may have been making as you were going. I want you to try these questions and then check your answers. And if you've made any mistakes, don't worry about it. You can just try it again. And that's the whole point. When you keep on trying and answering those questions, that's how you will embed that knowledge. So today we are going to be having a look at what is an embedded system. Before we have a look at what is an embedded system, we do need to understand what is a computer first. So a computer is any programmable machine or electronic device which takes in data, processes it, and then outputs the result. So this is that model, the input, process, output model that we've probably heard of before. Importantly as well, computers are general purpose. Now, when we say general purpose, it means that you can have multiple programs installed onto the computer and you can access them. You can use the computers for different reasons. So that is what is meant by general purpose. An embedded system is similar to a computer, however, it's kind of the opposite. So if you were going to answer a question about what is an embedded system, you could quite simply say it is a system that is built into a larger machine. That's accepted on the mark scheme. And not as a separate answer, but something you can add on to your answer. You can say that they are built for one purpose. And the good thing about an embedded system is once it's been made, it doesn't need updating for whichever machine that it's built into. So all of the components of the embedded system are usually built into a single circuit board. And we're going to look at a few examples now. So the first example is a washing machine. And this is top of the list on the mark scheme as well. So if you think of a washing machine, and if you were going to open it up, which I wouldn't recommend, you've got buttons on the front of your washing machine. And inside you've got a single circuit board that these buttons will interact with. And these buttons can do different things such as starting your wash. It could be to change the temperature. It could be to cancel the wash and so on. And all of these will interact with that single circuit board that is being built into this larger machine. Other examples include a microwave or a microwave if you're Nigella Lawson. Got a toaster. Notice that all of these are kitchen appliances, by the way. Apart from this, unless you use that in the kitchen. You've got a calculator, but there are loads more. So if you're trying to think of some examples in your exam, think kitchen. It's probably your easiest way to remember. Here are some example questions that you can practice. I would recommend pausing the video now and giving them a go. Don't forget, try and not look back at any notes that you've got in your book or try and not rewind the video. Give them a go first and then you can go back and see if you got them right. In this session, we're going to be looking at what are the main parts of the CPU. And a little bit later in the session, we're going to be looking at what's known as von Neumann Architecture, which is less confusing than it sounds. So we need to understand that the CPU has three main parts, and these are the control unit, the arithmetic and logic unit, and finally the cache. So we're going to start by talking about the control unit. Now the control unit manages the actual FDE cycle, which we've talked about before. So it manages the fetching of the instruction itself. Once it's fetched it and brought it back, it will then decode that instruction and it will execute the instruction, which as we know are the three main steps that are repeated billions of times in 1 second in the FDE cycle. So if data needs to be moved around the CPU or maybe moved back into main memory, then the control unit is the part of the CPU which will actually do that. The next part of the CPU is the arithmetic and logic unit. If you remember what that one stands for, then you'll be able to remember what it does really, because you've got the word in the title itself, the arithmetic part of it. So it does all of the calculations. And it performs logic operations such as and, or, and not. Now we'll do a completely separate video on Boolean operators and what logic gates and circuits look like. But all you need to know for now is that the arithmetic logic unit does all of the calculations and it does perform the logic operations. There has been questions in the past where you had to fill in the blanks. You had to fill in what these letters stood for. So it is worth understanding that the ALU does stand for Arithmetic Logic Unit, in case you are asked to fill in the blanks. So once the ALU has performed a calculation, it then has another part in it which you can see there called the accumulator. And the accumulator will actually store the results of the calculations themselves. And this is one of the registers of the CPU. And finally, we've got cache. Now, we have mentioned cache in a previous video. And the main definition that we understood last time was that it stores frequently used instructions. So when the FDE cycle is being carried out, the CPU will actually check cache to see if the data is there first. Now, if it's not in cache, then it'll go to RAM to fetch it, basically. Now, one thing that we didn't mention last time was that there are different levels of cache. So level 1 is the fastest, and because it's so fast, it does have the lowest amount of storage as well. And it kind of follows that pattern. So level 2 is not as fast, but then it can hold more data. And finally, we've got level 3, again, even slower, but it can hold the most data out of the 3 levels of cache. But your main thing that you need to know from cache is that it stores frequently used instructions. So they're the 3 main parts of the CPU, but now we're going to look at what's von Neumann architecture. Okay, so I've put together this diagram which hopefully makes it nice and simple to understand. So in terms of what von Neumann architecture actually is, it's a system where the CPU runs programs that are stored in memory. So as we know, the FDE cycle gets carried out billions of times in 1 second. And that's where the CPU will fetch instructions that are in memory. Now, the other parts that you can see in this diagram are the registers, which will actually help this process take place. So the program counter keeps track of what instruction that it's up to and will just increase every FDE cycle that's carried out. And it will pass that number to the memory address register. So let's say it was at instruction number 1. It will pass that number 1 to the memory address register. Now the CPU at that point knows that it needs to look in memory address register 1, which is in RAM or main memory. So at that point, it will do the fetch part of this cycle where it travels down to RAM and it will fetch whatever's in memory address 1, and it will bring it back and it will store it in the memory data register. Now at that point, going back to what the control unit does, it will actually decode that instruction and find out what it is that needs to happen. So it might be that it needs to perform a calculation, or it might be that it needs to move somewhere else in memory, and the control unit will make that happen. That's the execution part of it. If it was a calculation, the ALU or the arithmetic logic unit will carry out that calculation and then temporarily store it in the accumulator. The process just carried out again, so the program counter is increased to 2, and it will then start that cycle again where it will then fetch whatever's in memory address register 2, and then it will bring it back to the MDR, and the control unit will take care of it. It will decode that instruction and it will execute whatever needs to happen next. So it's a relatively difficult but short topic that people get a little bit confused on, but it's actually fairly simple when you think about what you need to know. And we've got some example questions for you to try out. So most of these are based on ones that we've had in the past, and try and not look back in your notes when you're answering these, and pause the video and then you can go back and check and see if you've got them right. The repetition of this is what will make this topic much easier, especially when it comes to thinking of the different registers and what their purpose are with the CPU. In today's session, we are looking at what is memory. So a lot of people make the mistake of thinking that memory is how much storage you've got in your computer, and that is not what memory is. Do not make the mistake of saying that memory is the same thing as your secondary storage device like your hard drive. That is not what memory is. Main memory is your RAM. So it's where programs and data are stored while they're being used. So as we know, we've got our CPU, works very closely with the RAM, and it will fetch instructions from the open programs that are currently stored in RAM. Now, if I've got software on my computer like PowerPoint, it's actually stored long term in my secondary storage device, such as a hard drive or a solid state drive. But because your secondary storage device is relatively slow, when it's in use, it does get copied into RAM. Now, the reason for that is because RAM is so much faster than your secondary storage device. Now, because it was only copied there temporarily, if the computer was to be turned off, your main memory would forget what was currently stored in it. The word for that when it's forgotten is volatile. Now let's have a look at another type of memory. So the next one is read-only memory, or ROM. Now you've probably heard the terminology read-only before, and it's usually on when you open like a Word document on Teams or something like that. And sometimes it's on there as read-only, and it quite literally means that you can only read from it, you can't write to it at all. Now the reason for that is because it contains some very important information in there, which are the instructions that your computer needs to boot up, which is your BIOS. If you were to accidentally overwrite that information, then your computer might not be able to boot up again. Now, if I turn off my computer, unlike RAM, which forgets everything when you turn it off, your ROM will remember it all because it is non-volatile. So everything's still there even after the computer is switched off. So let's look at our final type of memory. We've got something called virtual memory. Now, virtual memory is not necessarily a good thing. It's when your secondary storage gets used as extra RAM. What that means is your RAM or your main memory is full. It means you've filled it to capacity. And when it's full, that's when your secondary storage device steps in and says, right, I will act as RAM so that you can free up a little bit of space. So whichever piece of software that you've currently got open that you've not used for a while will be the one which gets moved into your secondary storage device as virtual memory. Well, as you know, the CPU fetches the instructions from RAM. So what has to happen is the software which is currently in virtual memory has to be moved back to RAM before it can be read by the CPU. Now this process is really slow, which is why virtual memory is not necessarily a good thing. Okay, so to finish with, we've got some exam questions on our memory topic. So what is the purpose of main memory in a computer? We've got to explain why Mr. Moore might need more RAM in his computer. What is meant by virtual memory? And finally, is ROM volatile or non-volatile? Explain your answer. So as always, I would recommend not checking back in your notes if you can. Try and answer these from your recall and then checking to see if you got them right afterwards. And if you didn't, don't worry about it. You can just keep attempting those questions until they are firmly lodged into your long-term memory. This session, we are doing what is a secondary storage device. I want to just talk about one of the most common mistakes that people make when it comes to that word secondary. When people see the word secondary, they assume that it means that it's a backup from the original storage. So it's not the first storage device, it's the second storage device. Now that is a load of rubbish. That is not true. Do not make that mistake. So your secondary storage is your long-term storage. If you're going to describe it, if you were asked to define or explain what is meant by the term secondary storage, it'll be a 2-mark answer. And these are the two things that you need to say. That it's long-term storage, and you could say even after the device is switched off. But then there's that other word in there, non-volatile, which is what that means. So the files are going to be there even after the device is switched off. Okay, so here's the kind of things that you can store with your secondary storage device. So general files like your Word documents, your PowerPoints and things like that. Audio files, most common you'd probably store MP3 files. Video files like an MP4. Images like a PNG or a JPEG, that kind of thing. And your programs, which is something that people often forget, will also be stored in here. Alright, so when we talk about storage, they like to ask about the different types of storage. Sometimes which one's the most suitable for a situation. So these are the 3 main types of storage. We've got optical, we've got magnetic, and solid state. So let's have a little look at optical storage first. So if we've got some examples so you can picture it a little bit easier. So a CD is an optical storage device, a DVD. When you're asked questions about why you would choose optical storage, you need to be able to justify why you think optical storage is better than another type of storage, or maybe worse than another type of storage, depending on whether you need to argue for or against. So to do that, we need to know about the characteristics. So let's have a look at the good characteristics of optical storage first. So it's really cheap. So if you're going to buy a CD, for example, it's really cheap. So if you needed something very quick to put something on, and it's probably disposable, you're not going to use it again, it's good that it's not going to cost you a lot of money for that reason. Also, it's portable. There was an exam question a long time ago now, and it was talking about which storage device would be the most suitable to go on the front of a magazine, and the answer was it was optical storage, and that was because it's portable, it's flat, and it's cheap as well. So those are some of the reasons why you would choose optical storage. But let's have a look at some of the bad characteristics of optical storage. So it's got a slow write speed, and what that means is if you were going to put files on there, it does take quite a while. It's not durable, so they scratch really easy, which can be an issue. It can't be read anymore by the laser, and then it's not going to work anymore. And they have relatively low storage. Even the Blu-ray disc, which out of those three has got the most storage, it's still pretty low storage compared to other storage mediums. Next, we're going to look at magnetic storage. So let's do some examples first. So most common one is the hard drive, which is probably the one that most people have heard of. Most computers do come with a hard drive, and we'll talk about characteristics why in a moment. Not as common, we've got the tape drive, and definitely not as common, we've got the floppy disk. So let's have a look at the characteristics of magnetic storage. So first of all, what's good about them? Buy a hard drive really cheap nowadays. It wouldn't cost you much money to have a really high amount of storage for not that much money. They're pretty durable as well. Usually people use internal hard drives, which means that they don't get moved around much, which means that they're very unlikely to break from being banged or something like that. And as previously mentioned, they've got really high storage capacities as well. So let's have a look at some of the bad characteristics of magnetic storage. So it's got a really slow write speed. It's still slow. It's marginally faster than optical storage write speeds, but it's still not quick enough to use it as an advantage. And it's not portable majority of the time. I mentioned earlier an internal hard drive. You can buy external hard drives which are plugged in via USB, but majority of hard drives are internal. I know I've talked mainly about the hard drive here because that's the most common magnetic storage device. So when you're thinking of magnetic, try and think hard drive. It's unlikely you're going to be asked for more than one example of magnetic storage device, but just in case you are, we've got these other ones, the tape drive and the floppy disk. And finally, we've got solid state storage. So let's have a look at some examples first. So we've got USB drives. Don't fall into the trap of just saying USB. That will not get you the mark on its own. It's got to be USB drive. SD cards, like they go in a camera. Micro SD cards, if you're maybe upgrading the memory in your phone or your Nintendo Switch. And nice and easy to remember because it's almost exactly the same as the title, the solid state drive. So let's have a look at some of the characteristics of solid state storage. So this is going to be the best overall storage device that you can choose. So it's got some really good characteristics. It's portable. It's durable. So if you dropped it, it's unlikely to break. It's got very high storage capacity, and it's got a really fast write speed. And that's due to having no moving parts inside. So really fast write speed. So that's probably its biggest advantage. But it does have only one bad characteristic, which is it is very expensive. It's very expensive because it's so good. Okay, so here are some questions for you to practice. I'd recommend giving them a go. Try and answer them without looking back on the video or looking back into your notes. There's plenty of questions here that you can have a little go at. I just wanted to point out that at the bottom, we've got a 6-mark answer, which was a previous question on an exam where you had to describe the characteristics between magnetic and solid state storage devices. And for a 6-marker, you had to come up with the different characteristics and why one would be better in a certain situation. So it was quite an ask really, but it would be a really good practice for your extended writing if you can give that one a go as well. In this session, we are going to be looking at how to convert between file sizes. So to understand this a little bit better, we do need to find out what is binary. Now, this is a term that a lot of us have probably heard about binary before, but we do need to recap it just so that we've got a good understanding of what our most basic file size actually starts at, and then we can build from there so we've got a good understanding of why and how we're going to be converting between these file sizes. So in terms of a definition about what binary actually is, which has been a question on previous papers, computers use ones and zeros to represent the flow of electricity, which is probably not the definition which you were expecting for what binary is. A lot of people will put something like the language the computer understands and things like that, which isn't necessarily wrong, but in terms of an accurate definition, this is what binary actually is. All data is converted to binary so that it can be processed. Like we've just kind of mentioned, the computer does only understand binary, so that's why it has to be converted into binary or machine code, as it's sometimes referred to, so that the computer can then process that information and figure out what the instructions actually are. Here's the key bit that we needed to know. The smallest unit of measurement is what we call a bit, or a single one, or a zero. Now, when it comes to file sizes, the bit is the smallest file size possible that we need to know about in our exam. When we hear the word file size, what does that actually mean? So it's the amount of actual storage that a file will take up on a secondary storage device. So if I was gonna store a picture onto my hard drive, for example, it's how much space that it's gonna take up in the hard drive, or how much storage it's actually gonna use. Now, these are the different file sizes that we need to know about for the exam. So a bit is our very beginning. It's the smallest file size that we need. And if we've got 4 bits, we can refer to that as a nibble. 8 bits is 1 byte. Now, this is where we come to what I usually refer to as the magic number, 1024. Now, you are allowed to use a rounded version of that where you round it down to 1000, and that's much easier to deal with, and we're going to talk about that in a little bit. So 1000 bytes, or 1024 bytes to be precise, is 1 kilobyte. 1024 kilobytes is 1 megabyte. 1024 megabytes is 1 gigabyte. 1024 gigabytes is 1 terabyte. And finally, 1024 terabytes is 1 petabyte. So that, you can see, is why I call it the magic number, because look how many times that number comes up. As long as you can remember 1000 or 1024, that makes our job so much easier when it comes to doing the actual conversions themselves. Now, there are known file sizes that are bigger than this and smaller. However, these are the ones that we need to be able to convert between for our exam. In the exam, unfortunately, it's non-calculator, and they do phrase some of the questions in some ways which makes it a little bit tricky to figure out what it is that it's asking of us. So we're going to have a little look at a few ways that we can approach these kinds of questions. So here's an example one. How many megabytes are there in 1 terabyte? Now, I've purposely done this because a lot of people would think, oh, well, it'll just be something easy, like how many gigabytes are in 1 terabyte, and we'd just say 1000. But notice that I've not gone for that. I've gone for megabytes, so gigabytes is in between the megabytes and the terabyte here. So to do that, we know that there's 1000 megabytes in 1 gigabyte. So all we had to do there was multiply it by 1000. So 1 times 1000, that gives us 1 gigabyte. Notice that I didn't use the 1024 here. I've just gone for 1000 because it's much easier to deal with, and it's accepted on the mark scheme to use the rounded number. But because we're now at gigabytes, we then need to multiply that again by 1000, because that's how we're going to get to 1 terabyte. So in other words, there are 1 million megabytes in 1 terabyte. Now, as you can see by looking at that, the easiest way of doing that would just be to add the zeros onto the end of the 1, because we've got 6 zeros there, which gives us 1 million megabytes. but you can do it 1 times 1,000 times 1,000. That will also give us our correct answer, which is 1 million megabytes in 1 terabyte. Let's have a look at another one. So Mr. Moore has a 2 terabyte hard drive. An image is 1 megabyte. How many images can Mr. Moore store on his hard drive? So this is almost the exact same question that we've just had. However, look how differently it's been worded. And you would just need to not overthink it and just think, well, I need to know how many megabytes are in 1 terabyte. And once we have our answer, we can just multiply it by 2 because it's 2 terabytes. So again, 1 megabyte times 1,000, that gets us to 1 gigabyte. We then multiply that by 1,000, which gives us 1 terabyte. And finally, we know that there's 1 million images in 1 terabyte, so we can just times that by 2. So the answer would be 2 million images in 2 terabytes if they were all exactly 1 megabyte. That's a lot of images. Okay, so to finish, I've got some more exam questions for you to practice, very similar to the ones that we've just done, but ones that we've definitely seen in the past on previous papers. So how many bits are in a byte? How many kilobytes are in 1 gigabyte? And finally, similar to one on our previous slide, Mr. Moore has an image that is 2 megabytes. How many copies of the image could Mr. Moore fit in a 2 gigabyte hard drive? So in this session, we are going to be learning how to convert between denary and binary. And the first thing we need to know is what number system we use. Now, it can be referred to a few different things. You've got denary or denary, as some people say. You've got decimal or base 10. Now, the reason it gets called base 10 is probably the most accurate name for it. And that's because we use 10 different values in our number system. So we've got from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, the binary number system can be referred to as base 2, and that's because it's only got 2 different values that it can possibly be, which is a 1 or a 0. Now, for the sake of your exam, you only need to be able to do up to 1 byte of information, which our maximum binary number that we are going to be able to make with that will be the denary 255. Now, you're going to want to always draw this table out in your exam because it will help you with your conversions. So if you ever see a binary conversion, there's lots of space on your paper, just draw this table out. You've got note pages at the back. You just want to use the time. You've got plenty of time. Don't try and just do it in your head. Just make sure you do the conversion to double check your answer. And this is what it looks like. Now, if you're no good with powers of 2, which all of these are, you can just start at the right-hand side with the number 1, and you can keep on doubling it until you get to 128. So we're going to start with 1, we double it to get 2, we double it to get 4, 8, 16, 32, 64, 128. So here's how we would write the number 1 in binary. And as you can see, I've written it as a byte. I've got 7 zeros, and then my final one, I've put a 1 there because I needed that top value from the headings in that table to represent what a 1 looks like in binary. Now let's try it with the value 2. So I've got 0 for the first 6 this time, but then I've got a 1 where the 2 is, because that's what number I'm trying to make now. I didn't need the 1 value at the end, so I've got a 0 there now. So we're going up one at a time. So here's how we would write 3 out in binary, because I've got a 1 in both the 1 column and the 2 column. That means that I've written out the binary for the denary 3. Let's look at a couple more examples. So if this was an exam question, convert the denary 88 into binary. So again, we're going to start by writing out our conversion table. So what we need to look at is which of these numbers do we need to add up to make 88. Now we know that 128 is too big. Okay, that one, it's over the value 88, so we don't need that one. However, we do want 64. That's the highest number that can fit into 88. So we need to try and make another 24 out of what we've got left. So 32 is too high. But if I add 16, that's going to bring me to 80. So we're really close now. Okay, so we're currently at 80. Now if I add another 8, we have made it, okay? That's all we would need to make the number 88. However, we've not given our answer in a byte yet, so we would need to finish this off, and we would put a 0 in the remaining columns there. We're going to look at another one which is a little bit trickier, but it's only tricky because it's quite a relatively high number, and you're not allowed to use a calculator in your exam, unfortunately. So you do need to be able to do this addition yourself. Now, don't forget, you can use your note pages to do any addition in any way you want. It's usually a 2-mark answer when you do a conversion like this, and each mark makes a massive difference in computer science, so don't make any mistakes with your adding up. Now, the first trick that we're going to go for is that these two, 128 add 64, these two add up to 192. So if you can remember that, you are going to save yourself quite a lot of your battle straight away, because you're dealing with quite big numbers here. And the tricky bit is where people are going to try and add numbers to go over the 200 mark. But that just comes with practice, that the more of these that you do in your head, you will get much faster at doing these. So at that point, we know we need to use both of these because we are trying to make 209 and we're currently at 192. If I added 32 to that, we'd be way over, so we're not going to need that one. However, if I add 16 to that one, that's going to bring us to 208, which puts me really close to our answer. So all I need to do now is find another 1, so we can put a 0 for all of these here. And finally, we need a 1, and we've made 209. Now, what happens if we get it the other way round and they give you the binary number and they say convert this into a denary number? Now, if anything, this is actually easier because all you've got to do is write out that binary number into your conversion table. So we're going to do it just underneath. So 1, 0, 1, 1, 0, 1, 0, 0, like this. Okay. And again, this comes into your practice of adding everything up where there's a 1. So 128 add 32 is going to give us 160. We're going to add 16 to that, which gives us 176. We're going to add 4 to that, which gives us 180. So this is the binary for the denary, 180. Okay, so to finish with, we've got some questions just to practice your conversions, which are relatively straightforward. So our first one, convert the denary 45 into binary. Second question is convert the denary 112 into binary. Question 3, convert the denary 231 into binary. And then I've got 3 binary conversions as well there for you. So carrying on from our last session where we're converting into binary, we are now going to learn how to add binary values together. So just as a little warm up, let's first of all do a couple of conversions, and then we're going to use our method to add them together. So we're going to start by doing the conversion for 98. Now, we don't need 128 because that is too high, but we do need 64 and 32 because that's going to bring us to 96. So we're actually really close at this point. All we're going to need is our 2, and that gives us 98. So that was a relatively straightforward one. So now we need 142. So we know that we can squeeze in 128, but 64, 32 and 16 are going to put us over 142, so we don't need those. So the first thing that we're going to add onto that is 8, which brings us to 136. If I add another 4 to that, that's going to bring us to 140. We're really close now. We're just going to add another 2, which gets us our answer. We don't need this final value, so we're just going to put that as a 0. So at this point, we've got 2 binary values, and we are going to learn how to add these 2 together. So I'm just going to put a little line underneath that. So the method here is if we have a 0 and a 0, we add those together, it's going to give us 0. 0 add 1 is going to give us 1. 1 add 0 is going to give us 1. 1 add 1 is going to give us a 0, carry 1. 1 add 1 add 1 is going to give us a 1, carry 1. Now the problem comes in when we've got an answer of 2, and that's because you can't write the number 2 in binary. So if I was to look at this point here, we've got a 1 add a 1. Now that's not going to work for us. So because if I was going to write a 2 in binary, we would need to write it as 1, 0 like this. This is why I've written down there that it's 0, carry 1, because we've got the 0 here, and we're going to carry this 1. And in a similar way again, if we've got 1, add 1, and we're going to carry 1, that's because, we can't write the number 3 in binary, but we can put a 1 here and here to make the number 3. So that's why we're going to put the 1 as our answer, and then we're going to carry this 1. Okay, so let's carry out the addition, and we'll use those rules on the side, and hopefully it'll become a little bit more obvious as to what's going on here. So we're going to add 0 and 0. This is going to give us a 0. 1 add 1. We know that we can't represent that by writing 2, so we're going to put 0, and we're going to carry 1. 1 add 1 is going to give us 0, carry 1. 1 add 1 is going to be a 0, carry 1. 0 add 1 is going to give us 1. 1 add 0 is going to give us 1. 1 add 0 is going to give us 1. And then finally 0 add 1 is going to give us 1. So this is how we add two binary values together. There's no requirement to then convert that into denary by adding up all these values across the top. We don't need to do that. It will usually tell you how to express your answer, and it will usually just say to add them together, which is fine to leave it as a byte in binary. Similar to our last session, you will get 1 mark for each nibble that you get correct. So if I just draw a line down the middle of that, you would get 1 mark for getting this side of it right. You would get another mark for getting this side of it right. Okay, so I'm going to add these together now, and let's see what happens. So 1 add 0 is going to give us 1. 0 add 1 is going to give us 1. 0 add 0 is going to give us 0. 1 add 0 is going to give us 1. 0 add 1 is going to give us 1. 1 add 1 is going to give us 0, carry 1. 0 add 1 is going to give us 1. But 1 add 1 is going to give us a 0, but then it should be a carry 1. Now I'm just going to park this carried 1 over here for now. But I just want to read this question again. It says, give your answer as a byte. Now we know that 8 bits are in a byte. So this is all you would need to write down on your exam. If you wrote down this extra digit here, you could lose a mark for that because it specifically says give your answer as a byte. So don't fall into that trap. It's not incorrect by having an extra value carried at the end. We're going to talk about that in a minute. But if it specifically says give your answer as a byte, just keep in mind that a byte is 8 bits. So you need to keep your answer at 8 bits. So at that point there, you would make sure that you didn't have this written on your paper. You just kept it like that as your answer. But it does bring us to an important point that we did have an extra value carried over at the end. Now this gets a special name, which is an overflow error, and we're going to talk about it now. So exactly as we've just done then, when you're adding binary results together, you could get more bits than the CPU was expecting, and that's what's known as an overflow error. You might get a question in your exam asking what is meant by an overflow error. This is the kind of answer that you could give, that it's more bits than the CPU is expecting, but as a little bit more detail that you can give there, you can say that it could cause software to crash if it can't deal with that extra bit. So often software is written pretty well and it can handle those extra bits, and it knows that it's going to store them somewhere else, and that'll prevent the software from crashing. Okay, so to finish with today, I've got some exam questions to practice. So I've got 3 sets of bytes here that you can add together separately. I would recommend doing it on a scrap piece of paper. You can get your conversion chart out if that helps as well. Now I've not specified here if you need to give your answer as a byte or not. So if it's going to give you an overflow error, then go with it. That's fine. You write that overflow error down as a 9th bit. We are going to be looking at how to perform a binary shift. This is a typical question that you might get in your exam. Perform a 2-place binary shift to the left. And as you can see, what we've got there, we've got an 8-bit number there. Now, hopefully you know your left from your right. That will obviously make a difference. We have been asked to shift to the left by 2 places. Okay, we know our left from our right, and we can count to 2. So what I'm going to do, I'm just going to draw an arrow from each of them, just so that you can really make sure you've got this correct. So I'm going to draw that one. Is going to go 2 places to the left, like that. Okay, so that one is going to be a 1 at this position, because we've gone from this position here. We've gone 2 to the left, which has brought us here. So that 1 has moved over here. All right. And this one is also going to move 2. Everything is going to move 2 to the left. So if we just draw this out, so we've got 1, 1, 0, 0. And then we've got 1, 0. Now, unfortunately, these 2 have fell off the end. Okay, they have gone too far. We want to keep this as an 8-bit binary number. So those 2 have gone, disappeared. But that only leaves us with 6 bits filled in, and we've not done anything with the side on the right. So what we're going to do is just fill it with zeros. And that's it. It is as simple as that. So you move exactly the number that it says, 2 places, we went in the left direction, and we filled it with zeros. Now let's look at the exact same question, but this time instead of shifting to the left, we are going to shift to the right. This time I'm going to start at the other side, and these ones are going to go 2 places to the right, like this. Okay, all of them are going to just go 2 places to the right. So I will do this one is moving over here. So I'm going to put my 1 just there. Let's carry on writing it out. So we've got another 1, 0, 1, 0, and 0. Okay, so everything has been moved to the right. However, this one and this one fell off the end. They don't exist anymore. They've gone. So at that point, we've got a gap over on the left-hand side because this time we shifted to the right. So we are going to fill it with zeros. Now, it is only going to be a 1-mark question on your exam this if you get a binary shift. However, they can ask you to describe the effect that it has, and that's what we're going to have a look at now. So for the first example that we looked at, we shifted everything to the left. Now, it has a different effect on the actual binary number by shifting to the left, and that effect is it multiplies the number. So if you were to shift it 1 place to the left, that actually multiplies the number by 2. And if you were going to shift it 2 places to the left, that is going to multiply it by 4. And finally, if you were going to shift it 3 places to the left, that will multiply the number by 8. Now, you won't be asked for any more than that in your exam. They may ask you that what effect does it have making a binary shift to the left by 3 places, and that's a 2-mark answer if you've been asked to describe that. But it's very, very unlikely it's going to go in higher than that. But it does carry on with that pattern. So if it did shift 4 places to the left, it would multiply it by 16. You can also divide in binary by using the binary shift. And it just quite simply is going the opposite way. So it's multiply if it's going to the left, and it's division if it's going to the right. So if you wanted to divide by 2, you would do a 1-place shift to the right. If you wanted to divide by 4, it's 2 places to the right. And finally, if you want to divide by 8, it is 3 places to the right. So we've got some exam questions to practice on the binary shift. As always, it's probably best if you pause the video and give it a go, and then if you need to go watch back just to double check your answer, then that's fine, but try and answer them all without looking at your notes in your book, and then obviously check afterwards to see if you got them correct. In today's session, we are going to be looking at what is a character set. Now, you might be asked in your exam, explain what is meant by a character set. Now, if it says the word explain, you should know by now that that is a command word, and that is going to be a 2-mark answer if you're asked to explain something. So if you're asked explain what is meant by a character set, your answer is the characters that can be represented by a computer system. What does that actually mean? Now, when I say computer system, obviously we don't actually need to be using a computer or a laptop. We could be talking about just general devices like a smartphone. If you were going to be messaging someone on your smartphone, you are going to be using things like uppercase characters, lowercase characters, numbers, symbols, and emoji, and so on. And all of those need to be stored inside your device. But as you know, the computer can only process binary information, machine code. So if you were to enter a letter on your keyboard, it has to be converted into binary so that it knows what it is that you've done so that it can then be displayed on the screen correctly. The computer does that using something known as the character set, characters that can be represented by your computer system. Now, a really common character set is ASCII. Now, ASCII is a 7-bit character set. However, it does have a 0 at the beginning of all ASCII characters, which is going to make it into an 8-bit character set. And each character is given a code, and that code is stored in binary, which takes up 1 byte, which, as we know, 1 byte is 8 bits. So as we said earlier, if you were to press a key on your keyboard, that will send that signal to the computer telling it which key was pressed. And then the computer uses that character set to translate that binary code into that particular character. So at that point, it would be outputted on the screen and you get exactly what it is that you've asked for. So another character set that we need to be aware of is Unicode. And Unicode uses multiple bytes. So we were looking at ASCII earlier, that only used 1 byte of information, whereas Unicode uses multiple bytes. And because it's got multiple bytes of information, it can store millions of possible characters, which is obviously enough to cover all major languages, which is great if you want to change your keyboard on your device to a different language. And as we mentioned earlier, ASCII is actually a subset of Unicode. So the first 128 codes of Unicode are exactly the same as ASCII. In the latest exam, there was an unusual question which asked you to write down the binary for an ASCII character. So we need to be able to write out the ASCII character alphabet, and it is really straightforward to remember as long as we follow these steps. So let's do an example. Write the binary for the ASCII character J. Now notice that this is a capital J, and that makes a difference to how we're going to start our byte of information. If it's a capital letter, like this one is, we're going to start our byte with 010. But if it was a lowercase j, you would start with 011 instead. Now, we do need to know our alphabet to do these questions, so it might be an idea, just so we don't make any mistakes, use your note pages at the back of your book. I would write out your alphabet if you were asked to do one of these in your exam, and then that way there can be no mistakes. So J is the 10th letter of the alphabet. So we're going to write the binary for 10. So we're going to use our good old conversion table. At the beginning of it, you can see we've got our 010. So 0 in 128, 1 in 64, and 0 in 32. But then the rest of this binary number, you just needed to make the number 10 in binary, where we've got an 8 and we've got a 2. So this is J in ASCII. So let's do one more example. So if we were going to convert the lowercase character P, for example, we would first need to count out how many letters in the letter P is. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So it's the 16th letter in the alphabet, and we said we're going to do a lowercase letter. So the lowercase p is going to look like we're going to have a 0 at the beginning. It's lowercase, so we want a 1, 1. And we need to make 16 for the letter P. So we're going to put a 1 there, which is 16, and the rest can be 0. And that is a lowercase p. So to finish, here's some exam questions that you can have a little practice of. So I want to know what is meant by a character set. How many bits is ASCII written in? We've got a couple of conversions, which is a capital letter Q and then a lowercase t into ASCII binary. And then finally, a bit of practice based on the last video as well. Once you've converted it into binary, I want you to then convert it into hexadecimal. So as always, pause the video at this point, give the questions a go without rewinding back or checking in your notes, and then obviously check your answers afterwards. Just repetition is key to making sure that you are confident in these areas. In today's session, we are going to be looking at what is an image. So images are made up of tiny dots called pixels. There's thousands of dots in every single image. Every pixel is a different color. And to know what color to light up that pixel to actually create the image, it has to get a specific code, which is a binary code, so that it knows what color to become. The amount of colors actually depends on how many bits are available for each of the different pixels. So what I mean by that, if we think about our binary conversion chart where we often use 8 bits, if we were to use just one of those bits, there'd be 2 colors available if it was a 1 or a 0 in that one position. And if we were to use 4 bits, so like a nibble, there are 16 different possible combinations. So like you've got 0000, 0001, 0010, and so on. And there's 16 different combinations that you can make there, which means there'd be 16 different colors available with 4 bits. 24 bits would be over 16 million colors available. And to calculate that, there is actually a way of calculating it. So you can just do 2 to the power of n, where n is the number of bits per pixel. So for example, if we were just using our 8-bit conversion chart like we've done loads of times with our binary conversions, we can do 2 to the power of 8, which gives us 256, which is a really quick way of working it out. The other way of working it out is if you had a 1 in every single position of our conversion chart and added it all up together, it would give you 255, but then there's the null value as well if they were all zeros, which means in total we've got 256 colours available with 8 bits. So that means that each bit could be one of those 256 colours. But if we then use 24 bits, because there's so many colours available, that means that the overall file size of the image is going to be much larger. What is image resolution? So image resolution is quite simply the number of pixels that are in an image, and you can calculate it a bit like you would in maths if you were calculating the area of a square. So you just do the width times the height. So if an image has more pixels, it will be much higher quality because there's more dots available in that picture. So there's more quality there. However, because there's more pixels, that means you're going to have more binary information stored about that image, which means that the overall file size is going to be much bigger. So there's 2 things so far that's affected the file size. The number of pixels that are available, which is the resolution, and the number of bits per pixel, which is the color depth. So all of those pixels can be a number of possible colors. So the higher those are, the higher the file size overall. Now, when it comes to storage on the computer, you can actually calculate how many bits the image is going to take up. And there's a little formula that we can do for it. So first of all, we can do the width times the height, like we did to calculate the resolution and how many pixels are in the image. But then we can also multiply that by the color depth by how many bits are in each pixel. Let's say that one image uses 3 different colors. Now we know we need at least 2 bits to be able to create 3 different colors. So this image next to me has got 25 different pixels. So to calculate this resolution, I did 5 times by 5. And then because the number of bits needed was 2, I'm then going to times that by 2. So in total, that's going to give us 50 bits to store the image. Now, you may be asked to calculate how many bits are in an image, but they may ask you to give your answer in something like bytes or kilobytes, depending on the size of the image. But in the question itself, it will give you all the information that you need to know to be able to do this. Just remember to multiply them all together. Okay, finally, we need to talk about something called metadata. it's been a question on past exams a couple of times actually. Explain what is meant by metadata, and it is one that throws people off. It's a 2-mark answer. So in terms of a definition, metadata stores additional image information. So if you wrote that and then gave some examples of metadata, then you would get your 2 marks. Another thing that you can write about metadata when explaining is it helps the computer recreate the image on screen from the binary data in each pixel. So these are the examples. So with things like your file format, the width, height, color depth, resolution. There's sometimes more than that as well. That's just a few of the examples. Like GPS information will be on there as well. Okay, so that's it for your image representation topic. We've got some questions that we can practice. So question number 1, state what is meant by the term resolution. Because it's a state question, it's often only a 1-mark answer, that one. Describe how images are represented in binary. State what is meant by metadata. Give one example of metadata that could be stored alongside an image. Explain how reducing the number of colours in an image can reduce its file size. And finally, calculate how many bits an image uses with a resolution of 15 by 9, which uses 16 colours. So as always, give these questions a go before you check back in your notes or anything like that. And then obviously if you're not sure, then go back, watch the video again and check your notes again. In this session, we are going to be looking at how is sound stored. So if we were going to be recording a sound, we would use a microphone, a bit like this one. Now this is an analog signal. However, if it was going to be stored onto a computer, it has to be converted into digital data. It's called an analog to digital converter. But how is sound converted? So we take what's known as samples of the amplitude of the wave at regular intervals. You can only take amplitude based on values in a certain bit depth. If you think back to our last lesson on image representation, so if we think about each of the pixels could only be a certain number of colors based on how many bits were in each pixel. Well, this is the same kind of thing, but for sound. So the more bits that are available, the more possible sounds that it can be. And that's what's known as bit depth. Okay, so in terms of what we need to know and think about in our answer, we need to think about what affects the size and the quality overall. So sample frequency is how many samples are taken in 1 second. We mentioned earlier sometimes it would be called sampling, but sample frequency is probably the more common name for it. Now, a really common sample frequency is 44,100 samples every second. But it is measured in hertz, which is the same as saying 44.1 kilohertz. And as we said before, the bit depth is the number of bits available for each of those samples. So if you think every second there's 44,100 samples, and if there's more possible sounds available, then it's going to increase the file size significantly. But because you've got more possible sounds, it will be closer to the original sound, which means it's going to be higher quality overall. Now, we can calculate the size of a sound just by the information that we know about it. So we've got our sample frequency, which is how many samples it is per second, which is measured in hertz. That's going to be multiplied by the bit depth. And then finally, you will multiply that by how many seconds the sound is. So if you had 20 seconds of audio with a bit depth of 8 bits and a sample rate of 1,000, then all you need to do is multiply it all together. So 20 times by 8 times by 1,000, which will give you 160,000 bits or 160 bytes. So if you're trying to think about what you need to include in your answer, it can be quite difficult to remember it. So I've got a stupid but easy way to remember it. So these are the 2 things that we know already that we need to include in our answer. We've got bit depth and the sample frequency, because they're the 2 things that will affect the overall quality and the file size itself. So your way of remembering is blue ducks sound funny. So you've got BD, blue ducks, which is bit depth, and then sound funny, sample frequency, which is the SF part of it. So if we can remember blue ducks sound funny, we need to think that we need to include bit depth and sample frequency in our answer, because they are the 2 things that affect the file size and the quality. If you were asked a question such as explain what affects the overall file size of a sound file, you could give an answer something like the more samples per second will give a more accurate sound to the original, and that's the sample frequency. And to expand on that, you can put the bit depth will affect how many possible sounds can be stored digitally. And overall, increasing the sample frequency or bit depth will improve the quality, but will also increase the file size. The bottom point that I've made there, increasing the sample frequency or bit depth will improve the quality but increase the file size. That's enough to get you a 2-mark answer. However, for a more detailed answer, if it was like a 3 or 4 marker, you would have to include the other points as well. So to finish with, we've got some example questions that you can practice. We've got describe how sampling is used when storing sound. Explain the effect of the sampling frequency on the size and the quality of the sound file recorded. State what is meant by the sound bit depth. And finally, calculate how many bits would be in a sound that has 30 seconds of audio with a bit depth of 8 bits and a sample rate of 500 hertz. Show your working. In this session, we are going to be looking at what is compression. So I always think it's quite easy to remember what compression is because we can think of it like crushing a can. So if you've had a can of Coke, something like that, finish with your can, you will often, with shoes, crush that can and then you will recycle it. But when you crush it down, you've still got the whole can there, but you've made it smaller so it takes up less space. And that is what compression is. But there's different forms of compression, so we need to talk about that. So in terms of a definition, you're reducing the file size, but you're trying to keep the file as true to the original as possible. Now, there's different reasons why you would compress a file. The main one is just so it takes up less space on your secondary storage device. So let's say you've got a hard drive in your computer and you want to store as many files as possible on there. So the files are going to be compressed so that you can store the maximum amount possible. In addition to that, if you're going to download something from the internet, it's going to be much faster. If it takes up less storage, then the file itself will download faster. So I'm not sure how many of you have tried to attach files to an email. There's actually a maximum of 25 megabytes that you can attach to an email. If you have got smaller files, you'll be able to fit more files onto the email as an attachment. And finally, if you're on the internet using a browser, the web pages themselves will actually load quicker if they've got smaller file sizes and less information to pull down. So I mentioned earlier we've got 2 different types of compression. Now your 2 different types are lossy and lossless compression. Let's have a look at lossy compression first. Now if you've got a file such as a JPEG, which is an image file, lossy compression will actually reduce the number of colours available in that image. So it'll reduce the amount of bits needed per pixel. That's the colour depth that we were talking about in our image representation video. So less bits available per pixel means that there will be less colours available per pixel. But because there's now less colours available, it means that the image itself won't look as clear because the colours aren't going to be as accurate to the original actual colour. But because there's less binary information per pixel, it is going to reduce the overall file size. The other thing that happens during lossy compression is the actual overall number of pixels could be reduced. Now, when you're using certain software, you can actually choose how much compression you want to apply to an image when you are saving it or a different file. So if you're going to heavily compress it, it's going to really reduce the file size by a lot. However, the more you compress an image, it's going to look less and less like the original, but it will have a smaller file size because overall you've got less pixels and colors available. So obviously it comes with some advantages. Having a smaller file size and using lossy compression, you can store more files. And often the images which are compressed like this, like a JPEG, are compatible with most software, so you can open it on pretty much any piece of software you've got on your computer. And with the small file size, it means that it can also be downloaded really quickly. As mentioned though, it does come with some disadvantages as well. So once the data has been removed, it is actually gone permanently. So if you reduce the amount of pixels, you can't get those back, and it will have lower quality overall. And lossy compression can't actually be applied to a text file. Now that seems like a weird point to make, but in the past it's asked in an exam which would be the most appropriate type of compression to use on a text file, and you wouldn't have been able to choose lossy compression as your answer, because if lossy compression was applied to a text file, it would actually be missing information from that text file. So if you are asked a question like that in your exam, you cannot apply lossy compression to text files. So the other type of compression we've got is lossless compression. Now this is kind of similar to my analogy before about the can of Coke. So lossless compression temporarily removes data from a file and then restores it when it's opened. So it's a bit like, if you can think of it, crushing down, and then if you need it, you then open it again. That's like lossless compression. Now the way it does this is by remembering the information from the file in a bit of a different way. So it will follow an algorithm so it knows what information is stored about that file. So if we were talking about an image file such as a PNG, that's an example of lossless compression. Now if the next 50 pixels were all red, rather than saying red pixel, red pixel, red pixel, red pixel, it would just say 50 red pixels, which is going to reduce the number of binary information that's needed to store that image file. But then when it comes to actually recreating that image, if it was suddenly in use, it would know exactly what information to include in that image because all of the information is right there. It's just stored in a bit of a different way because of the algorithm. And the proper name for that method is called run length encoding, but you don't really need to know that for your exam. All you need to know is that it temporarily removes the data and then it will restore it when the file is in use and it's been opened. Again, it comes with some advantages and disadvantages. So the biggest advantage is that there's no reduction in quality. It will look or sound as true to the original as possible. You can use it on text files, and obviously it can be decompressed back to its original form. Disadvantages: it will reduce the file size, but nowhere near as much as lossy compression will reduce the file size. And they will take longer to download because they've got that larger file size. Okay, so some exam questions to practice on this topic. So Mr. Moore wants to compress a text file. Which type of compression is the most appropriate? Justify your answer. Explain why Mr. Moore might want to compress his audio files. And finally, explain why lossy compression is suitable for a video clip, but it is not suitable for a text document. So in this session, we're going to be looking at what is a network. So a nice definition of what is a network is two or more devices that are connected. Now, I purposely use the word devices there because a lot of people think that it has to be a computer, like a desktop computer, to be a network, but that's not true. That's why we use the word devices, because it's more of a generic term for different kinds of devices like laptops, phones, and that kind of thing. And in terms of what a network actually is used for and what it does, they are used to share information and resources. So we've got some advantages and disadvantages of using a network. So the advantages: you can share your files with each other easily. Working in a school, it's much easier to share my files with all the students because I can just put them into one place on the network and all of the students can find that file nice and easily. So I find it a massive advantage of using a network by sharing files. As I mentioned earlier, sharing hardware, so any printers that you might just have one printer in the room or in the building and everyone shares that one printer because no matter where you are, if you send your work to print, you can get it from that one printer rather than every single computer having its own printer, which will be a massive cost. So depending on the type of network that you've got, you can have user accounts. So if you come in and you sit at one machine, then you can log in, which is ideal if you come in and the computer's not working, or if maybe you've been moved in a new seating plan and that kind of thing, you can still access all of your work. And from a technician point of view, a technician will find it much easier to install software on all of the devices on the network because they can just do it centrally and to all of the computers that are part of the network or selected computers. And that includes any updates as well. So disadvantages of a network. It's expensive to set up a network because you've got to buy network hardware, which is a really big cost initially. And also an expert is often required. And when I say expert, I'm talking about a network technician who will actually set up the network and maintain it. And also another disadvantage is viruses can affect multiple devices. Okay, so we're just going to talk about two different types of network now. And the first one is a LAN. So what is a LAN? So LAN stands for Local Area Network. So as a nice definition of what a LAN is, so if you were asked in your exam, explain what is meant by a LAN, that would be a 2-mark question. You would answer something like, devices that are connected in a small geographical location within 1 mile on a single site. That single site bit at the end is quite important. That on its own can get you an extra mark. So a local area network can be wired or wireless, and you will often find them in places like schools and small businesses. Now, one important feature of a LAN as well is that the companies or schools or businesses themselves will own the cables and hardware for the LAN. So they will have actually paid for all of their network cables, all of the switches and the servers and so on. The other type of network we're looking at today is a WAN. So what is a WAN? It stands for Wide Area Network, or sometimes Wider Area Network. What we mean by that, as a definition, is devices that are connected over a large geographical location. And as you can guess, it's kind of the opposite of a LAN because it's over 1 mile and it's across multiple sites. So it could be that you have like a huge business, and the business has got sites in different parts of the country, or it may be over different countries across worldwide, but they're all linked together it could be through satellite links or radio links, telephone lines, and so on. Now, because the company themselves won't own something like telephone lines, they will have to hire these lines to be able to connect their network together, and that's a huge cost if you're setting up a WAN. Okay, so some exam questions to practice. So we've got explain 2 advantages of using a network. Mr. Moore wants to set up a network for his small business. What type of network would this be? Justify your answer. Explain what is meant by a WAN and state 2 disadvantages Mr. Moore may face when setting up a home network. So I'm going to give you the chance to pause this now, and then we will go through the answers. Okay, let's go through the answers then. So explain 2 advantages of using a network. So your first one you could have had was sharing files. Users can easily share files to work collaboratively. So you got 1 mark for writing sharing files, and then the little bit afterwards is the explanation, which we'll get the 2nd mark for. Sharing hardware, for example printers, this will reduce cost as an explanation. And finally, user accounts, log in from any device in the network. So that will be enough for the 2nd mark, but if you wanted to go into more detail, you could put if a computer stops working, the user can move to another computer and still access their work. Mr. Moore wants to set up a network for a small business. What type of network would this be? Justify your answer. So it would be a local area network, which is within 1 building, small geographical location, not across multiple sites. And as a final reason to justify it, it will allow file sharing between colleagues. So explain what is meant by a WAN. It's a wide area network across multiple sites over a large distance. And finally, state 2 disadvantages Mr. Moore may face when setting up a home network. So the cost to set up the network initially, and may possibly need an expert to set up the network. In this session, we are going to be looking at what affects the performance of a network. Things that can affect the performance of a network. But the main ones are going to be bandwidth, depending on whether it's wired or wireless, the network. Interference on wireless networks, and your choice of hardware, so what hardware you've bought when you set up the network. So what is bandwidth? So bandwidth is the amount of data that can be transferred in a given time. So this is where my little weird picture comes from with these cars and the lanes. So if you think about my drive in the morning to work where I go on the motorway, if it's at say 3 in the morning, there's not going to be much traffic, which is another word that you can actually use when describing a network. And if it's busy, lots of people using it, you can say there's lots of traffic. But if too much data is transferred at one time, the performance will slow down. So it's a bit like if I leave at rush hour in the morning, there's going to be tons and tons of cars there, and I will definitely slow down with my journey to work. It's going to take me a lot longer to get there. And it's exactly the same when using a network. If there's lots of users logged in, lots of people using the services of the network, logging in at the same time, or trying to access a file at the same time, because all of those users are going to be sending traffic, then it's going to really slow down the network. So when you set up a network, you can choose whether you're going to set up as a wired network or a wireless network. Now, wired networks are faster and more reliable than wireless. A regular Ethernet cable usually has around 10 times faster transfer rate than it does a wireless network. But then lots of networks will use fiber optic as well, which is even faster than that. And we will do a lesson on network hardware, which goes into a bit more detail about each one and which one performs the best. But also wireless is affected by things like interference, which is just quite literally physical obstructions like the walls and doors. So if you're sat upstairs in your bedroom and you're using a wireless network to connect to your router downstairs or something like that, and you've got your door closed because you don't want to wake anybody up while you're talking to your friends or something like that, then that is a physical obstruction, and it will affect the performance of your device. But also, your devices have only got limited range. So if you live in quite a large house, for example, and your bedroom is further away, then it will also affect the performance of your device if it's operating wirelessly. Depending on your budget and how much money you've got to set up your network, your choice of hardware will affect the performance of the network as well. Because there's multiple pieces of hardware that do a similar job, but some of them do it in a much more efficient way. So if you can afford the more expensive one, it will affect the performance of your network in a positive way. One piece of hardware that would affect the performance of your network is if you had to choose a hub over a switch or vice versa. So you would normally always go for a switch rather than a hub, because with a hub you have more data collisions, whereas a switch, because it uses a MAC address, all data goes directly to where it needs to be, which means there's less collisions, which means it'll perform much faster. And also, when you're actually buying the cabling for your network, if you can choose fiber optic cables, then that will have much better performance than a copper cable. But again, fiber optic cable is much more expensive, so it depends on how much budget you've got when you're setting up your network. Okay, just some questions to practice on what affects the performance of a network. So state 2 ways Mr. Moore could improve the wireless network performance in the upstairs bedroom. Mr. Moore switched from using a wireless network to a wired network. Explain how introducing a wired network could speed up the performance. Mr. Moore has a family of 5. How can bandwidth affect the performance of a network? So I'm just going to give you the chance to pause the video and give these questions a go, and we're going to go through the answers very shortly. Okay, let's go through the answers. So state 2 ways Mr. Moore could improve the wireless network performance in the upstairs bedroom. So you could reduce the interference between the bedroom and the router, and you could move your network hardware closer to the bedroom. Mr. Moore switched from using a wireless network to a wired network. Explain how introducing a wired network could speed up the performance. So wired networks are not affected by interference. This will provide a consistent, strong connection. And finally, Mr. Moore has a family of 5. How can bandwidth affect the performance of a network? So each device connected to the network will use bandwidth. If more devices are connected, performance will slow down. This video is about network hardware, what hardware is and what software is. But this specifically is asking, what is network hardware? So as we know, hardware is something physical that you can touch. Network hardware are devices that are needed to allow communication between devices. So using the network hardware, you can build a network. Now for your exam, you need to know the different common pieces of network hardware and what the differences are between them. So the first one I'm going to talk about is the NIC, or network interface controller, or network interface card sometimes. So quite often these are found just as a separate card inside older devices, but most of the time now they are built into the motherboards themselves. These just allow you to plug in your Ethernet cable so that you can connect to the internet. It's probably one of the most common cables that you'll have seen. So the next device, which is probably the most common one that you'll hear about on your exam, is what we call a network switch. Now a switch is a very clever device because it will remember where other devices are on the network using the MAC address. And because of that, it makes it really secure, and it doesn't broadcast any information to any other device. It will send the data directly to the device it's intended to go to. So this device is the router. I'm guessing most people have probably heard of that one. Most people have got a router in their home, and if you get asked, what does a router do? About 9 people out of 10 will probably say it connects you to the internet. Now, yes, when we're at home, we will connect to our router. However, the actual job of the router, if you're describing it, is very different. So routers are used to connect multiple devices together. In terms of sending data, you could describe it as forwarding packets to the correct destination, or you could say receiving packets. So the next one is our WAP, our wireless access point. So if you think of a network, say in a school, you might not be able to visibly see these because quite often they're found underneath, those tiles in the ceiling which you can move. And It will allow other devices such as laptops and phones, tablets to join the network. Okay, next is cabling in a network. So the most common cable that you will come across is the Ethernet cable. And you won't really need to know this for your exam, but the most common forms of Ethernet cable are Cat5e and Cat6. The actual structure of these cables, they are made using copper wire, sometimes referred to as a twisted pair. And the reason that happens is to reduce interference, which allows the data to travel quicker. Another really common cable is coaxial cables. Now, they are very cheap. They're surrounded by plastic, and it is a single copper wire. And they have a metallic mesh around them, not on the outside of the case, but inside of them, which will also shield against that interference that we've just been talking about. And finally, your last cable is fiber optic. Now, you've probably heard of this when you sign up for, say, your internet, like fiber broadband, that kind of thing. Data is transmitted extremely fast because it's transmitted as light. So it's really expensive to install this, but it's actually really effective, and the data can travel very fast. Those are our most common types of network hardware. We've got some questions to practice as well. So this was one from a past exam, so this is quite a difficult one. So if you want to scroll back on the video and have a little look at it, some of the differences between a router and a switch. Now, as always, it's a 4-mark question, which means you need to come up with at least 2 differences, but then you need to explain the difference between those in a little bit greater detail. Next one, what is the role of a router? Remember to include that some of our key terminology, things like packets, forwarding and receiving from destination. And finally, explain why Mr. Moore should use a switch that is not a Nintendo Switch, a network switch, when creating a LAN. Okay, so let's go through the answer to those then. So what are the differences between a router and a switch? So a router connects you to the internet. A switch connects devices on a local area network. A router uses IP addresses for communication between devices. A switch uses MAC addresses. What is the role of a router? So a router forwards packets to the correct destination. A router connects multiple networks together. And finally, explain why Mr. Moore should use a switch when creating a LAN. It allows communication between devices, meaning data and files can be shared easily. And finally, it allows secure connections between devices due to using devices' MAC address. This video is about client-server networks or peer-to-peer networks. So when you set up a network, you need to make a decision about whether or not you want it to be a client-server network or a peer-to-peer network. Both of them have advantages and both of them have disadvantages. So it is purely about your situation and the reasons why you would want to choose one over the other one. So first we're going to look at what is a client-server network. As you can guess from the name, a client-server network is managed by a server. And just to recap, a server is a powerful computer which has lots of functionality, often used for different reasons. But in this case, you can think that all of the clients, which are the people that would log in and access the network, they will type in their username and password, and then they will pull all of that information from the server so that they can see everything they need to and have access to certain things. In a school situation, the technician is usually the person who will decide what things people can access from the server, whether they can access certain areas, whether they can access certain software, and so on. So as I said, all of the devices that are connected to the server are known as clients. And the client is the person that asks for the data by logging in, and then the server responds to that request. So the server stores the user profiles, and all of those files are stored centrally. Now, the good things about a client-server network is that all of the files are stored centrally, which means that you don't have to take up the storage on one particular computer, and you can, let's say you come in one day and your computer has stopped working, then you can move to another computer and still log in and still access all of your files because they are pulled from the server as you log into that account on that other device. From a technician's point of view, they're really good because you can install software on all of the devices that are connected to it, and you can perform updates rather than going to each individual computer to install the software and perform these updates. And as I mentioned briefly, you can set user access levels. So if you think of it from a school, a teacher might be able to see some part of a system that other users, maybe students, might not be able to see, something like confidential information, for example. So there are some disadvantages of a client-server network. It is expensive to set up, and that's because the actual server itself is going to cost a lot of money. There's going to be a lot of cabling involved, and so on. So it is a high cost initially to set up. You do need an expert. Now when I say expert, I'm referring to a technician, like an IT technician. You will have to employ a network technician to be able to manage that server. And the final disadvantage is that because you're solely relying on that server, if you came in one day and the server wasn't working, then nobody would be able to access those files at all. So the other option is a peer-to-peer network, and you don't need a server for this one. All of the devices are equal in a peer-to-peer network, and because each device is individual, each person's computer is their own, and they can store their own files on their own device. So quite often these are used for smaller networks, like in a home or a small office, and you can still share files between these devices. So for the advantages of a peer-to-peer network, they are easy to set up, so you won't need to employ a technician to be able to do this for you. Most people can do it without much training. You don't depend on that server, which is often ideal if you just want to come in and get on with your work. You know where to find everything on your own computer. You don't need a login. As long as you're sat at the same place, you can access all of your things and know exactly where everything is. And you can still share files between these devices, which is, if that's all you wanted to do, then that's all you need. Now, there are some disadvantages of it. If you came in one day and your computer was broken for whatever reason, then you can't move to another computer as your files are not central. So that might be you out of action for the entire day. And because you don't need to log into these devices, they're not as secure. Okay, so we've got some exam questions to practice on this topic. So we've got describe what is meant by a client-server network, describe what is meant by a peer-to-peer network. Mr. Moore wants to set up a network at his house. Recommend what type of network he should choose, and then justify your answer. So that justify is what makes it a 3-mark question. So you would get a mark for choosing the right type of network, and then an extra 2 marks for a correct justification of whichever network you've chosen. And then finally, identify 2 benefits of using a client-server network. Okay, let's go through the answers then. So first one, describe what is meant by a client-server network. So you would get some marks if you'd said all the devices connected to the server are known as clients. You'd also get a mark if you say a client requests data, the server processes the request, and then responds. Then we've got describe what is meant by a peer-to-peer network. So no server is needed. All devices are equal when sending information. Files are stored on individual devices rather than centrally. So Mr. Moore wanted to set up a network at his house. Recommend what type of network he should choose, then justify your answer. So Mr. Moore should use a peer-to-peer network because it is easy to set up, no experts required, and then this will still allow file sharing for easy sharing of files between family members. And finally, we've got identify 2 benefits of using a client-server network. Files are stored centrally so that clients can move to another computer and still access their work. And finally, we can set user access levels, which makes it more secure. So this is so users don't accidentally delete or move important work and files on the network. And also, you could have said won't have access to anything confidential that other people might need to have access to. In this video, we're going to be looking at what is a network topology. A lot of people get confused over the word topology. It's just a fancy way of saying the way the network is laid out. So when someone sets up a network, they've got to make a decision on what they think will be best for the network in terms of how the traffic and the data is getting sent and what's the fastest, most efficient way, but also managing that network. And that's when they decide on what network topology that they're going to use. Now for your exam, the only 2 that we need to know about now is the star topology and the mesh topology. So we're going to look at those, but there are a few other topologies that if you're interested, you can also do some further research on. So the first one we're going to look at is what is a star network topology. This is a common mistake that a lot of people make, and the central device is what we call a switch or a hub. And a lot of people think it's the server, but that's not the case. You've got this central device, which is called the switch. Now, the switch is a piece of network hardware, and all of your different devices, like all of your PCs that are attached, like your printer and things like that, they're all going to be attached to your central device, your switch. And it's what allows the communication between all of the different devices. Now, most commonly on your exam, you're going to be asked for the advantages and disadvantages of a star network topology, but you may be asked to draw one as well. But just if you are asked to draw one, then you need to remember that you've got this central device is going to be your switch. Don't put your server in the middle. And you don't need to do any fancy drawings of like a PC. You can just do like a little box and then just write and label it. So PC, switch, just keep it simple. So for your advantages of the star network topology, your network will continue to operate if a device fails. So think of it from a school's point of view. Let's say you go into a classroom and one of the computers has, for whatever reason, stopped working. Now, the user can just move to a different PC, they can log in, and then they can still access all of their information. Whereas on older network topologies, if that computer had failed, then the whole network would stop working. So it's a really big advantage of a star network is that you can just move to a different PC and still access all of your information. So it's got really good performance. Because the switch is quite a clever piece of network hardware, there's very few, if not zero, data collisions. And what that means is when you're sending data at the same time as somebody else, the data is not going to have any collisions, which slows down the network usually quite significantly. Because of your central device, which is the switch, data goes directly to where it needs to, then you're going to have very few collisions. Okay, it's a lot easier to add extra devices as well. So there's a proper word for this, which is scalability, and that is where you are increasing the number of devices that you've got on that network. So it's easily scalable. So you don't get asked this as often, but you may be asked for the disadvantages of a star network topology. So we need to know these as well. So first one is that it's actually really expensive. Now, you've got a lot of cabling, you've got network hardware involved, and you're also going to need to pay a technician to maintain this network. So you've got the extra cost of employing someone to look after this network. So it's quite expensive. So that I'm actually going to put as a separate disadvantage, that an expert is required. So if you had a very small business, you may not want to employ somebody else to come and operate this network for you. You might want to just do everything yourself. Whereas actually you need a bit of expertise, maybe a bit of extra training to be able to maintain one of these networks. The final disadvantage I've got for you is if that central device breaks, so the switch or the hub, then the whole network will stop working. So the other topology we're going to look at is the mesh network topology. Now, as you can see from the little diagram, you don't need a central device on this one. So you're already going to save a little bit of cost because you don't need to buy as much network hardware. All of the devices are fully connected. Sometimes it's referred to as a fully connected network. And the data will choose the fastest route between those devices. So because it's fully connected, there's no single point that the network can break, which is a big advantage. Now, as a disadvantage, because you've got so much cabling between all of these different devices, it is very expensive to set up. But you can have a wireless mesh, which obviously would save some cost on all of that cabling. That's all you need to know for network topology, so let's have some exam questions to practice. So question 1, explain 2 advantages of a star network topology. Now just keep in mind we've got that word explain in there and it's actually worth 4 marks. So you need to tell me what the advantage is and then why it's an advantage. Question 2, Mr. Moore has set up a mesh topology instead of a star network topology. Explain 1 advantage and 1 disadvantage of a mesh topology compared to a star topology. And then finally, what is the central device of a star network topology? Alright, let's run through the answers then. So, explain 2 advantages of a star network topology. So, network continues to operate if a device fails. That will get you your first mark. To ensure users can work for the maximum amount of time. That will get your second mark because you're explaining why that is an advantage. Few data collisions, so better performance. That's your next mark. This means that when sharing files, the network will run faster. So Mr. Moore set up a mesh topology instead of a star network topology. Explain 1 advantage and 1 disadvantage of a mesh topology compared to a star topology. So the advantage, no central device like a switch needed to connect all devices together, which will save cost. And for your disadvantage, initially expensive to set up due to having all of that cabling. And your final question, so what is the central device of a star network topology? The answer is a switch, or if you put hub, it will be accepted as well. So today we're going to be looking at the topic of DNS and how DNS is used to convert a URL into an IP address. Now, before we get into what DNS actually is, we need to understand a little bit more about the World Wide Web. So let's say you're about to make a website and you're going to buy something called a domain. So the domain is the actual name that people will remember. So like bbc.co.uk or ebay.co.uk. So this is the actual domain that we remember, the eBay part of it, for example, or Mr. More CS. Now, when somebody buys a domain, it has to be hosted on something known as a web server. Now, when I say hosted, it means that that's where people will actually connect to be able to access the website itself. So people will pay for their website to be hosted on a web server somewhere in the world. So the URL is usually nice and memorable. It's why they're so expensive for ones which are really short and easy to remember. Now, because that website is being stored on a web server, to be able to access that web server, we would need something known as an IP address. Now, an IP address is just a long string of numbers, which is the location of where that is. So because we are able to remember the name of a domain, but it's unlikely that we can remember the IP address of where that website will be stored, that's where DNS is used so that you don't have to remember the IP address. The DNS part of it will translate the name of the website into the IP address so that you don't need to remember the IP address, and then your website will still appear in front of you on your browser. So you can think of it a bit like a phone book. So you might not remember your friend's mobile number, but you remember their name, hopefully. So let's say you've got a friend called Bob. You can click on Bob and it will call Bob. However, you probably don't remember Bob's number off the top of your head. So all you need to remember is the name Bob. You click on it, it dials it. And it works in the exact same way with DNS, because you can remember the name of the website, but not the number that's associated with it. So these are the steps that are involved with DNS. So the website gets hosted on a web server. We've already talked about that. The web server has an IP address. Your browser, something like Google Chrome or Edge, sends the URL to DNS, which, don't forget, is like a system which is being used. So DNS will then find that IP address that's linked to the URL. Now let's say you've made a spelling mistake and you've gone to type in Mr. More CS, but then you've actually put like Mr. More CD and it doesn't exist. Now, at first, DNS will try and pass that request to a higher DNS, which means it's going to look elsewhere to see if that website actually exists. But if it doesn't exist and it can't find it, it will just return an error. But if it does find it, that's when it will send all of that data to you and the website will load up correctly. So here's an example question about DNS where it doesn't actually use the word DNS in the question itself. So the IP address 192.130.129.226, say it's hard to remember, is linked to the website with the URL of mrmorecs.co.uk. When mrmorecs.co.uk is entered into a browser, the website homepage is loaded. Describe the relationship between the website URL, mrmorecs.co.uk, the IP address and the web server. So as you can see, it is talking about the process of DNS without talking about the process of DNS. So you need to realize that that's what it's talking about and then relay those different steps that I've given you on the previous slide. Now you could actually bullet point your answer on this one, but sometimes it's nice to just maybe use parts of the scenario as well. So if a user was going to visit mrmorecs.co.uk, they would type in the URL, but your answer could look like this. So the website hosted on a web server. The website/web server has an IP address. The browser sends the URL to DNS. The URL has a linked IP, so DNS finds the IP. If DNS can't find the IP, it passes it to a higher DNS, but if not found, an error is returned. And finally, the web server sends the web page and all that data to the user. Today we're going to be looking at how devices communicate. Devices communicate using something called standards, and they also use something called protocols. We're going to be looking at protocols next time, so don't worry too much about that one. So the reason devices communicate is so they can transmit data over a network. But let's have a look how they actually do that. A network standard is an agreement about the hardware and software which is going to be communicating and sending the data to each other. So a really common one that people have heard of, an Ethernet cable, but then there's also an Ethernet protocol as well for communication. And by having these standards, it just helps manufacturers to create products and software so they're compatible with other manufacturers so they can develop their own product, but then this is the standard that they will all use so they can still communicate with each other. Some really common ones include like on your web browsers where they agree that they'll use HTTP to communicate, or HTML. Now, if devices are on the same network as each other, there's a way that they can communicate with each other, and this is by using a unique address. If they're on the same network, they'll use something called a MAC address. Now, it's important we understand what a MAC address is, what it looks like, and the properties of a MAC address, so here it is. So a MAC address has 12 characters. The MAC address is unique to every device and it can't be changed. A MAC address is in hexadecimal, so if we look back at our data representation unit, we can see what hexadecimal looks like. And if we think about our network hardware, we discussed what a network switch was, and that is what will use the MAC address to be able to send the data to the right place. If the device is on a different network, it won't use a MAC address. It will use a different type of address, one that you probably heard of called an IP address. Now, IP stands for Internet Protocol. So if you remember what IP stands for, you'll probably remember that you would use that one to communicate over the internet. Now, there are two versions of IP address. There's IP version 4 and then there's IP version 6. So IP addresses can be reused, they can be changed, and can be automatically allocated when you're using the internet. They've started to use IP version 6, which is almost limitless in the amount of combinations of types of address that are available, so they can start assigning it to all the devices that are using the internet. An IP address will need to be allocated before that device can actually use the network. So we've got some practice questions to finish on, just on that short topic. Question number 1 is, what is a MAC address used for? Question number 2 is, explain what is meant by a network standard. Question number 2, how many bits is in IP version 6? And finally, explain how devices on a star network make use of a MAC address. Okay, let's run through the answers then. So question number 1, what is a MAC address used for? It is used for communications between devices on a same network. Question number 2, explain what is meant by a network standard. Standards allow manufacturers to create products and software that are compatible from other manufacturers. Question number 3, how many bits are in IP version 6? 128 bits. And finally, explain how devices on a star network make use of a MAC address. An answer you could have given is something like, when a device sends information to another device within the same network, a network switch will use the unique MAC address of the device to ensure that data reaches the correct device. Today we're going to look at what are network protocols. A network protocol is a definition, because you can sometimes get asked this on your exam, is what is meant by a network protocol. And as a definition, it's a set of rules for how devices communicate and transmit data across a network. So the protocol specifies how communication begins and then how it ends between those two devices. And it could be within the same network or it could be over the internet. But it's what will say how the data gets organized, and then if the data goes missing, what's going to happen next. Now, this isn't an exhaustive list. We're going to look at the protocols you need to know for your exam. So your first one, which is the one they like to ask the most questions about, is called TCP/IP. And it stands for Transmission Control Protocol, Internet Protocol. Now, TCP is probably like the main protocol which allows packets of data to reach where they're going and make sure that everything's spot on. So it will say how the devices are going to communicate, how that data is going to get split, how they get rearranged once they've arrived, and it will check that they've all been sent and delivered correctly. The IP part of that, as we've mentioned in a previous video, it stands for Internet Protocol, so you can think that if the data is going to be getting sent over the internet, then they need IP to make sure that it will reach their destination over the internet. Now, HTTP is probably one that you've definitely seen before at the top of your browser, maybe if you are on a website using Google Chrome, something like that. And it stands for Hypertext Transfer Protocol. As we said, it's what browsers will use to access the website and then communicate with the web servers wherever the website is being stored in the world. If we go on further than that, there's HTTPS, where the S then stands for secure. So any information that's being transmitted to that website, it could be like your username, password, email address, or anything like that, all of that information gets encrypted if it's using HTTPS to make sure that it's all secure when it's being sent. You'll find that the majority of websites use this nowadays, especially things like social medias. Basically, anywhere that you would be submitting any information will be using HTTPS, and if it's not, you shouldn't really be using that website. Another common protocol that we need to know about is one called FTP, which stands for File Transfer Protocol. And this is just a protocol which is used to access and then move files between devices over a network. So it could be that the files are stored somewhere on FTP server, and then you will use FTP to sort of communicate with that device and then pull all those files across. So the first one we're going to look at is one called POP3, which stands for Post Office Protocol version 3. Now, if we think once you're trying to access your emails, they are stored somewhere on a server, then if you receive those emails but don't want them to stay on the server, then you would use POP3 because then it will remove it from the server, but then you would then retrieve your email and still get it. But if you want it to stay on the server in case you want to access it again later, you could use one called IMAP, which stands for Internet Message Access Protocol. And this is where you will receive a copy of the email from the server instead, and it will still also exist on the server. The final email protocol is SMTP, which stands for Simple Mail Transfer Protocol. Even though the S stands for simple, a good way to remember this one is to pretend that the S stands for send instead, and then we can remember what this one's used for, which is for sending emails. There's a concept that we need to know for the exam, which is something called layers. And layers get considered and thought about because it helps us break down the complex problem about transferring data across a network. And in our last video, we talked about standards and how it can make products from other manufacturers make some sort of agreement and protocols that they're going to use to be able to communicate. We can focus on one area of the layers so that we can design software that's for one particular layer, and it will just simplify that whole process of how these devices are actually going to communicate. Now, in the 4-layer model, the layers that we need to know about are the application layer, the transport layer, the network layer, and the link layer. You can assume that these layers are what will decide whereabouts that protocol will sit in that process of communication between the devices. If a manufacturer wanted to develop a protocol which was around transferring files, then that would sit in the application layer, and they could develop then something which is similar to FTP, for example, or HTTP, because it's the transfer of data. If the manufacturer was looking at something around communication about how packets are going to be sent between devices, then that will be somewhere around the transport layer, which is things like TCP. So by understanding the layer model, it will just allow us to think about what protocols there are and whereabouts they would sit in development of new protocols for different manufacturers and their products. And as long as the data that is received in the correct format, then the layers don't need to worry about each other. They only need to worry about the one thing that they are doing. Okay, so a few extra questions today, but a little bit shorter on our answers, so hope you don't mind. So question number 1 is what is meant by a network protocol? Question number 2 is what is meant by a layer? Question number 3 is what is an advantage of using layers? And then I want you to identify protocols for the following scenarios. So first one is transferring files between devices over a network. Next one is encrypting information that is sent and received. And finally, for sending emails. Okay, let's have a little look at the answers then. So question number 1 is what is meant by network protocol? Nice simple answer. They are the rules for communication between devices on a network. Question number 2 is what is meant by a layer? And a layer is a group of protocols. And you could have written that layers are self-contained. Question number 3. What is an advantage of using layers? So layers can be changed without other layers being affected. Each layer has its own purpose that can be programmed individually. And a final advantage you could have written for that is manufacturers can focus on developing software for just one layer. Last little bit where we wanted to identify protocols for these scenarios. The first one, transferring files between devices over a network. You could use FTP. Next one is for encrypting information sent and received, we would use HTTPS because don't forget that S stands for secure. And finally, with sending emails, we would use SMTP.
Today we're going to be looking at what is meant by the cloud. Now, quite commonly when people think about the cloud, the first thing they think of is storage and things like iCloud and things like that. And they're not wrong, but there is way more to the cloud than you probably realize. Not only is it file storage, it is also different services that are available over the internet. Most businesses will have sort of servers which has and offers storage of files, which is what probably most people think of when they think of the cloud. And like I said, that is right. But what's really handy about it is because clients can use and access their files and the services over the internet. So sometimes this can be referred to as a cloud application. So there are tons and tons of different applications that you can access, quite often for free as well. And so some examples of it might be like a Google Slides, for example, or it could be Google Docs. And you've got other ones which are really common like Teams. And as we know, that was a massive thing that was used during lockdown because then people could access all of their files and still communicate and speak to each other with online lessons and things like that. Now, what's handy about it is that some of these applications are actually really powerful. So because of that, they get stored on a powerful server somewhere else. And then even with less expensive hardware that somebody might have at home, they can still access and use these powerful applications because they're actually being hosted somewhere else in the world on somebody else's server. The most common thing that's asked about the cloud in your exam are the advantages and disadvantages, and they can actually hold a lot of marks. They can often be worth 2 to 4 marks for then just the advantages, and then 4 marks possibly on the disadvantage as well. So if we nail this a little bit, then we'll do really well. And if you think every 7 marks is potentially another grade on your exam, then it holds a lot of weight in this bit. So we need to get this right. So we'll start with the advantages. So the first one is it's easy to increase how much storage you have available. Now, if you were a business, if you need to then back your answer up with why that's an advantage, you might start with the free version where you've got a certain amount of storage. But then let's say you start running out of storage, then you can pay and immediately get that extra storage and it's available to use straight away. Now, if you've got hardware or storage that you've got maybe within a school or a small business, you would have to pay someone like a technician to be able to manage all of that stuff for you, whereas other IT staff that are working, say for Google, will manage those for you, which is a massive advantage because it's going to save a business a lot of money as the explanation for the advantage. Now, whoever that host is, again, let's say it's Google, they're the ones that will manage the security and all the backups for you. So if there was a problem, then they are the ones in charge of that. They always keep it up to date for you, which is great. So you're always using the latest version of the software, whatever it is that you're using. And finally, as probably the biggest advantage of it, as long as you've got an internet connection, you can access your stuff. So you don't need to carry around like a pen drive with you or anything like that. You just need to be able to log in and then access that service. Let's have a look at the disadvantages of the cloud. Now, on the flip side to what we were just saying, if you've got no internet access, then you cannot access your things, which is a pretty big disadvantage. Now, we said before that the security is managed by the other company, which is good. However, it could be vulnerable to hackers. Now, if you've got a business which is storing loads of, let's say, large files, videos, then the actual subscription fee for that amount of storage can be quite expensive. Let's have a little practice with it then, and we're going to start with explain 2 advantages of using cloud-based storage. So we're being specific here about the storage elements of it, 2 advantages of it. And then for our second question, I want you to explain 1 disadvantage of using a cloud-based service. Right, let's run through the answers then. So to start with, explain 2 advantages of using cloud-based storage. Users can access files and applications anywhere with an internet connection, so you could work remotely if you were unwell. And you could have written as well, it's easy to increase how much storage is available, so if more storage is needed, then you could get it instantly. And potentially here's an answer for explain 1 disadvantage of using cloud-based services. So subscription fees for the cloud storage and applications can be expensive, which might be necessary depending on the service. Okay, that's it for this one. See you next time. Today we're going to be looking at malware and some other threats. Let's start by looking at what's meant by malware. So the word malware is broken down into malicious software. And don't forget, software are things like applications that are installed on the device itself. Now, you can't see malware. Often it's installed in the background so that you don't actually know that it's there, but it's harmful and it can be really damaging to your computer or device. Often they get installed so that they can edit, delete, or steal information. A way this could happen could be something like a Trojan virus, which is where you go to download something and you think it's one thing, but actually it installs malware on your computer and you don't even know that it's there. Another potential threat is unauthorized access. So unauthorized access is when someone's not been given permission to access data, but they access it anyway. There's multiple ways that this can happen. It's not just because somebody's left their laptop or device unattended. So one method could be by intercepting messages. As data is being transmitted, if it's not being encrypted, the data once it's intercepted can be read, or it could be copied, which means that they can gain access to your confidential information. Another method of unauthorized access is just by finding out someone's password, which we're going to be talking more about in a moment. As a result of unauthorized access, it could cause loss and cause damage. Now, sometimes people do this on purpose. Sometimes people accidentally cause damage once they've gained access to something by maybe moving an important file or deleting it. Now, there's different ways that people can find out someone's password. It could be through something called a brute force attack. A brute force attack is when a piece of software will try multiple combinations of passwords to try and find the correct password. A common prevention method of this is by having a strong password, which consists of a password having over 12 characters and has uppercase, lowercase characters, special characters, and numbers. Another method is by using social engineering techniques. Social engineering is where you trick someone into giving away their confidential information. A common example is something called phishing. Someone might open a malicious email which contains a link, and when they click on that link because they've been tricked into clicking on it, it will take them to a very believable website where they might enter their details and it will go back to the attacker. Other methods might include pretext phone calls, which is sometimes referred to as blagging. And this is over the phone where you trick someone into divulging some confidential information by making up a scenario that they might believe, like they've been in an accident or they're owed PPI. A final method we could talk about is shoulder surfing. Shoulder surfing is quite literally looking over somebody's shoulder to try and find out their password. This doesn't only have to be on a computer, it could also be at, say, a cash machine, at a checkout when people are entering their PIN, or to gain access to a locked room, like maybe a staff room at someone's workplace. The best prevention method of this is staff training and awareness. The more people talk about it, the more people know about it and what to look for, the dangers and signs, then they might not be victim to these attacks. Another thing I want to talk about today is something called user access levels. So when you join a network, you will have a different level of user access depending on who you are. So a network manager will have total access to everything so they can manage the network properly. But somebody else using the network might not have access to everything. For example, a student might not have access to program files in case they accidentally move or delete one. So there's 3 different levels of access that I want to talk about. The first one is called read-write access. This would be someone very high up, someone like the network manager, and they can view any files and they can make changes to them. Read-only access is where you can view the files and read them, but you can't make any changes to them. And finally, just having no access. You're not allowed to see them, you're not allowed to do anything to them. Okay, let's look at the questions for this topic. So describe 3 user access levels. Give 2 examples of social engineering. What is meant by malware, and explain the process of a brute force attack. Okay, let's go through the answers. So describe 3 user access levels. So we've got read-write access where you can view the files and make changes to them. We've got read-only access where you can view the files but you can't make changes to them. And there's no access where you can't view the files. Next one, give 2 examples of social engineering. So the ones that we've said were phishing, farming, pretext phone calls or blagging, or shoulder surfing. Next one is what is meant by malware. So if we break it down, it's malicious software designed to edit, delete or steal data. And finally, explain the process of a brute force attack. trying every combination of words and numbers until the password is guessed. Today we're going to be looking at online threats. So last time we were looking at general threats, whereas these threats are specifically looking at network threats. So a common one that a lot of people have heard of and often just refer to as DDoS is a denial of service attack, or DOS or DDoS. When you use a network, you're sending packets of information, and a DOS attack is when a large amount of packets are sent to a destination. Now, the sheer volume of this amount of information being sent is what's going to overload the server or bandwidth. This in itself can just stop a computer network from working. Now, the difference between a DOS and a DDoS is the extra D in DDoS stands for distributed. So a distributed denial of service is much harder to track as it comes from multiple places. One that I want to mention today, but we're going to go into in more detail in the next video, is something called an SQL injection. Now, SQL is a type of programming which is used to edit, search, and manage a database. If people use malicious SQL, they might be able to gain access to the database and steal the information or change it. This is often done through a website input and the website not being very well tested for any vulnerabilities. Now, we've got different ways of protecting that data. Let's have a little look at the prevention methods. So the first one, which is a really common one, is a firewall. A firewall will check all the different signals that are going in and out of a network. This will prevent any malware from entering the network. So if a packet looks suspicious, the firewall will prevent it from entering the network. Another common method is something called encryption. We've talked about encryption when we did protocols, when we were talking about HTTPS, with the S standing for secure. This is where all the data will get scrambled if it's getting sent, so that anybody who does intercept that data, it will be useless to them. Only people with an encryption key are the ones who can see that information. Different apps will use encryption called end-to-end encryption without you even realizing. A really common one might be on something like WhatsApp, so that when you're sending messages to other people, you can see it as plain text. As you send it, the message gets encrypted, and as it's received on the other end, that's when it becomes decrypted so that they can see it in plain text again. But anyone in between who tries to intercept that information, it'll be useless to them. Final method is penetration testing. This is where authorized people are allowed to try and break into the network and find vulnerabilities in it. And if they do find any weak points, they will report it back and they will work on fixing that area to make it more secure. As well as these, we've got physical security methods. These can be as simple as keeping computers in a locked room, or we might use something like biometrics. These are really common on smartphones where you've got things like Face ID, retinal scanners, fingerprint scanners, and so on. You might employ a security guard which will just stop any access unless they are authorized, and you could use a swipe card like I have for work, which is a little badge which will just get me in and out of the buildings. Okay, let's have a look at some questions on this topic then. So explain how penetration testing is used to make a system more secure. Identify 3 physical security methods. What is the purpose of encryption? What is SQL injection? Okay, let's run through the answers then. So explain how penetration testing is used to make a system more secure. You could have put something like, people try and break into a computer system to find weaknesses that can then be fixed. Next one, identify 3 physical security methods. So I went for security guard, locked rooms, swipe card entry. Next question is, what is the purpose of encryption? Data is unreadable by anyone who intercepts it. And finally, what is SQL injection? It's malicious SQL commands that are entered to steal or delete files from a database. Today we're going to look in more detail at what is meant by an SQL injection. So to start off with, let's just get a bit of an understanding of what SQL means. SQL stands for Structured Query Language. This is something that is used to edit, manage, add to, delete, search a database. Databases contain loads of really important information. This could be the information on a website, but it could also be user details. Often that's really valuable information to a hacker. So an SQL injection is a type of cyber attack where they will try and gain access to this information by using malicious SQL code. Now this will take place on websites that haven't been tested very thoroughly, and it could be somewhere where the user has to type in information. This could include somewhere like a login form or a search box on a website. Now, as the user's using the website like this is called user input. And if the website's got good web design, it will check what the user is putting in and it will clean that information before it's being inputted. So let's have a look at some methods of prevention of an SQL injection. The most common one is something called input validation. And if you think about that word validation and the word valid, when something's valid, it's correct. So only if the user is putting correct information will it it be allowed. This could be down to the type of information that somebody puts in. So if they were asked to enter their age, it might be that they're only allowed to put in an integer, or even better, it might come down with one of those little drop down calendars where you will choose the date that you were born, and then that way there's no way the user can type in information in that box. On some websites you could use something called a prepared statement. So rather than the user typing in something potentially into say like a search bar, you could use something called a placeholder. So for example, if you're on a shopping website and you're trying to find t-shirts, rather than them typing in t-shirts in a search bar, you would have a little drop down menu so that you can just click on the section that says t-shirt and it will run that SQL query for you so that the search is done without the user having to type any information that could potentially be malicious. Linking back to the last video, you might just not want to give them any access to anywhere that they shouldn't be able to access to, so we don't want to cause unauthorized access, so you will limit their access to different areas. And finally, a great method of prevention is again penetration testing in this case. So you will do regular checks on your system to see if there's any weaknesses, any vulnerabilities, and if there are, then you can go back and fix them. So just a couple of questions on this topic. So what is SQL injection? And explain a method of prevention for an SQL injection. Okay, let's run through the answers then. So what is SQL injection? It's malicious SQL commands are entered to steal or delete files from a database. And the other question is explain a method to prevent SQL injection. So I've gone for input validation. It's where we ensure all user input is checked and it only allows the expected type of data. And I've given a little example there as well. Numbers for age, no special characters for usernames. That would have been enough for the 2 marks, but you also could have gone for regular security testing. So you could use penetration testing to identify any vulnerabilities before the hackers do. And that's it for this one. I'll see you next time. Today we're going to be looking at different types of operating systems. When we've thought about software in the past, we're thinking about the different programs, the different apps that are installed on the computer. And an operating system is very similar. It's just software that runs on the computer. But the operating system is the thing that is in charge of the different hardware that's on your computer and any other software that is running. So the operating system itself is a platform that allows us to interact with it, but it also allows all of your other applications and programs to run. Now for us as people, it's not as easy to interact with a computer or a device. So we have something called a user interface, which is what we're looking at when we're using the operating system on the device. Now there's different types of user interface. All have got their advantages and disadvantages, and we're going to look at some of them now. So the first one we're going to look at is this, a graphical user interface, or GUI or GUI for short. And what you can see is just all the different icons that help people who may not have much experience using a device. It might make it easier for them to use. Now an easy way to think about this and remember it is something called WIMP. So for the W in WIMP, that stands for Windows, and you've got things like this as a window, which it allows us to interact with it and see different things that we might store or keep in different places. You can move the window around, you can resize it, whatever you want to do with it. The I stands for icons. So like in real life, they try and use pictures and icons that are relatable and can help us remember what we're going to actually use it for. So for example, I know that if I don't want something anymore, I can put it in the bin. And we've got an icon here of a recycle bin. Because it's relatable, we know what it would be used for. So if I don't want something, I can just move it and put it straight into the recycle bin. So it just allows us to remember what it should be used for and interact with the device in that way. So the M stands for menus. We've got tons of menus in the graphical user interface. For example, when I click on Start and go to all my programs, we've got a list here. This is our menu. We've also got different menus when we right click in places of different things that we can do as well. And then finally, we've got the P, which is for pointers. And you can see I've got my nice bright pink pointer, so I can see exactly what it is that I want, and I can just click wherever the pointer is and I'll be able to access it. Another type of menu is something called a command line interface. An example of a command line interface is command prompt, where we can type in commands and still control the device in this way. Other examples would include on a Linux operating system, you could use the terminal. So to use this, you just type in different commands so that you can control it. So for example, if I wanted to change which folder I'm currently looking in, which directory, I can do CD, which is for change directory. I can change to this one, which is what I want to look at. and send in that command, and now that's the directory that I'm looking in. If I wanted to make a directory, I can type in another command, mkdir, and then give it a name like example1. I'll press enter, send that command in. Let's open that folder now and look, and here is the folder that I've just created using that command. Other examples of user interface would include a menu-driven interface, which is a bit like when you get to a cash machine and your options come up on the screen in front of you, and then you've got different buttons that you would press on to interact with what it is that it says you can do. The final interface we want to talk about is a voice-activated interface. This could be something like Siri, where you would say Siri and then your command, and then it will listen to you, and then it should hopefully do what it is that you've asked it to do. It then might follow up with further questions and get you to interact with it in that way. For your operating system to manage all of this different software, it has to allocate memory to each of these different open applications. Now you can actually see how much memory is being allocated to different applications by doing this. Control-Alt-Delete on your keyboard, selecting Task Manager, and you can see what's currently open in this way. You can see at the moment I'm using about 39% of my memory for the current open applications. You've also got the different background processes which run in the background anyway, which are also using memory but not as much. Sometimes this is referred to as multitasking. So as you've seen, I've got different applications at the moment that are open, and to do that, the operating system has to multitask and run those different programs at the same time. Now, as we know, all the way back from our hardware unit, we've got the CPU, which is fetching, decoding those instructions that are coming from all the open applications. Multitasking allows that to happen smoothly, and the operating system will interact with the CPU to ensure that that is happening. Okay, let's have a look at a few questions on this topic. So question 1, explain the role of an operating system. Question 2, identify 3 types of user interface. And question 3, explain what is meant by memory management. Okay, let's go through some answers then. So question 1 was explain the role of an operating system. You could have written something like, an operating system is software that manages computer hardware and software resources. You could extend your explanation by saying the operating system provides a platform for applications to run. Question 2 is identify 3 types of user interface. So some of the ones we've looked at are graphical user interface, command line interface, and menu interface. Question 3 was explain what is meant by memory management. So you could have written something like the operating system allocates memory to different applications, transfers data between RAM and storage when needed. In this video, we're looking at system software. In the last video, we looked at operating systems and how it is software that manages both hardware and software resources. System software in this video is referring to the different software and processes that are available as part of your operating system. The first one that I want to have a look at is peripheral management and drivers. So first of all, let's look at what's meant by peripherals. Now, if you think peripheral vision, something that's on the outside, that should hopefully remind you about what is meant by peripheral, which is external devices. It could be things like a keyboard, a printer, a mouse, and so on. As part of system software, you can manage these different devices that are connected, and sometimes you need to install an update to make that device work properly. This is also known as a device driver. So a driver is actually software that allows the operating system to correctly communicate with the peripheral. If you connect a device that your operating system's never seen before, it might be that they can't communicate with each other. By installing the correct drivers, it will fix any bugs and allow that communication between the device and the operating system itself. This usually improves performance and enhances its capabilities, but will also fix any bugs that it might have been experiencing as well. Another feature of system software is user management. The operating system allows different users to have separate accounts. Now, it might be that different users like having things set up in a different way, so you can personalize your own profile so it's set up in the way that you like. Now, if different people are using the computer, it might be that you want to have different access rights. We've talked quite a lot about access rights in the past when we looked at our networks topic. But as a quick reminder, an admin might have access to more things than a guest might have. The admin might be able to make changes to the computer itself, install extra programs, whereas a guest might just be able to use the things that are already on there, but not make any actual changes to the computer itself. As part of a user management feature, you've also got security features as well. This can be setting up things like passwords, authentication, finger ID, and so on. Another feature of system software is file management. So when you've got your files stored in a hard drive or a solid state drive, it can be quite confusing for us to understand, but how we see it and interact with it is actually really easy. And that's because we store our files in a structured way in folders that we can recognize. So what we're looking at here is a folder that I've got on my computer. This is actually stored in a place on my hard drive. So for us to interact with it, we can click on the file that's inside it and we can perform different actions with it. Most of these actions are across the top here, so we can copy them, we can rename them, we can share them with other people, we can delete them, and we can move them. For example, I can drag and drop this one inside here, whereas actually that's changing the location of that on the hard drive. So as a final overview of system software file management, we've got naming, renaming files so they're given easy identification for us. We've got folder allocation so that files are stored in the different directories or folders as we call them. And we can move and save different files. Files can be copied, moved or deleted. And all of this comes under what we call file management. Okay, let's practice some questions on this topic. Question number 1, explain what is meant by a device driver. Question number 2, identify 2 features of user management. And question number 3, give 2 advantages to a user of file management. Okay, let's run through the answers then. So question 1 was explain what is meant by a device driver. You could have put something like software that allows the operating system to communicate with peripherals. They can add extra functionality to the devices. Question number 2 was identify 2 features of user management. So we could have gone for security and access rights. And for question number 3, give 2 advantages to a user of file management. I've gone for a user can rename files, that would get me 1 mark, so that they can be found and identified easily. So that's your second mark on that first advantage. You also could have gone for files can be stored in folders, that's 1 mark, so that they can be kept organized and found easily by the user. That's your second mark for that one. And in this video, we're going to be looking at utility software. Now, as a definition, utility software is system software that helps maintain and optimize a computer. So the first one we're going to look at is encryption software. Now, encryption is a feature that we've come across quite a few times, especially in the networks topic when we're sending information to other people. And it's very similar in this case, but it's just a feature of an operating system to also protect data. So encryption data protects data by converting it into an unreadable code. And like before, if anybody was to intercept it or try and get it, it will prevent unauthorized access to see that sensitive data that they might be after. Common examples will include BitLocker and VeraCrypt. If you've not seen BitLocker before, this comes as a feature on Windows computers. And if you plug in something like a pen drive, it might give you the option to encrypt the file using BitLocker. And what that will do, it will make it so that anybody else who tries to access that pen drive, it will require a password for them. And if they did manage to access the files without the password, all of it will be scrambled and it will be useless to them. The next one I want to talk about is disk defragmentation. Now, this is something that only happens to hard drives. It will optimize the hard drive so that the read and write speed is much faster. Over time, hard drives can become what we call fragmented. Now, what that means is that blocks of data of related files are usually stored next to each other on a hard drive. But if a file gets deleted, it might free up gaps on the hard drive. And as a new file is added, if it doesn't quite fit in that gap, it will go across multiple parts of the hard drive. So that now when it's going to read that information from the hard drive, it's got to look in more than one place to actually access the larger file that's taken up those blocks that became freed up in the first place. Disk defragmentation is the thing that moves the related files back together, so it's only looking in one place to see those related files, and that will speed up overall access. The final one that I want to look at is data compression. Now, we've looked at data compression before when we were doing our memory unit. Data compression reduces the file size. This is good because it will reduce the amount of storage that your files are taking up on the hard drive. But it also means if you're transferring data, it will speed up that process as well because it's got the smaller file size. Another advantage is it makes it faster to send files over the internet. We've got the 2 types of compression that we've already mentioned, which is lossy compression and lossless compression. One that we didn't talk about was zip folders for lossless compression. So if you were going to create a zip folder, you would select all of your files, you can right click and put them into a zip folder. This will compress all the files without removing any of the data. This makes it much easier to send to somebody else because the file size is much smaller and you can attach it to an email and send it to somebody over the internet. Okay, let's look at some questions for this topic. So question 1, what is the purpose of encryption software? Question 2, explain how files may have become fragmented on a hard disk drive. And question 3, what are 2 benefits of data compression? Okay, let's go through the answers then. So question 1, what is the purpose of encryption software? So encryption protects data by converting it into unreadable code. Question number 2, explain how files may have become fragmented on a hard disk drive. So it was a 3-marker, so we've gone into a little bit of extra detail on this one. So when files are saved in non-continuous blocks of free space, this will cause parts of the file to be scattered across different locations on the disk. As files are modified or deleted, gaps will form, leading to more fragmentation and making the read-write head take longer to access the data. And question 3, what are 2 benefits of data compression? It saves disk space and it makes it faster to send files over the internet. And that's it for this one. I'll see you next time. Today we are looking at legislation. When we think about legislation, we're talking about law and how it can affect our use of digital devices and other technology. So there's 4 pieces of legislation that we need to know about, not in and out because they're absolutely huge documents, but we need to have an understanding about what they are, why they're in place, and how they can affect technology. The first one we're going to have a look at is called the Data Protection Act. So the Data Protection Act is in place to make sure that organisations, a bit like a school or a business, are handling data properly. So if we think of it from a school point of view, schools collect data about their students and staff, and then they have to store it. Now, they have to have this data. They need to know like medical history. They need to know where you live. They need to be able to do things in certain situations, like if there was an emergency, who to contact. If there was a problem, again, who to contact, and so on. For schools to be able to store data, they have to do it responsibly. There's a phrase that's used for the Data Protection Act, and it's the key principles. This is what should be followed by organisations to make sure that they are handling data properly. So when collecting the data in the first place, it should be collected fairly. Once the organisations have got that data, it needs to be kept secure. You couldn't just leave it in like a tray. That would be breaking the Data Protection Act. A part of this as well is that a school would only store it for the amount of time necessary. Final one to keep in mind is that individuals have the right to be able to access their data. Okay, so the next one we're going to have a look at is called the Computer Misuse Act of 1990. As a general, what it's about, this prevents anybody from hacking and any cybercrime that goes on. What that means, it's illegal to be doing any hacking, creating any viruses or spreading them, or carrying out any cyber attacks. So there's 3 main offences that we're going to have a look at, but these are kind of overarching and lots of different things will come under these. They're just general terms for the majority of things that can go on in the Computer Misuse Act. There's going to be more specific cases, but they would probably categorise it under one of these 3 main things. The first one's unauthorised access, which is accessing anyone's data without permission. The next one is unauthorised modification of data, which means to change it unnecessarily. And that's usually done by spreading malware. And then finally, using computers for any type of fraud, which is cybercrime. The next one most people are quite familiar with, which is the Copyright Design and Patent Act of 1988. So this is what protects people's content, their digital content. And it means that people aren't allowed to copy things like books, images, videos, or anything without permission. It also protects intellectual property and makes sure that creators are getting paid for what they've made. This is also the act that allows legal action against piracy. This is stealing digital things without paying for it. Okay, so we've got some questions to practice about this topic. So what's the general purpose of the Data Protection Act? Give 2 offences covered by the Computer Misuse Act 1990. Why was the Computer Misuse Act introduced? Okay, let's go through the answers then. So question 1, what is the purpose of the Data Protection Act? So you could have written something like, it makes sure that personal data is collected, stored, and then used securely and fairly. So that'd get you 1 mark. Then you could extend it by saying it gives individuals the rights over their data, such as access and correction. Second question, give 2 offences covered by the Computer Misuse Act 1990. So you get 1 mark for saying unauthorized access to data, and then you could get another mark by suggesting something like spreading malware or modifying data without permission. And finally, why was the Computer Misuse Act introduced? To prevent unauthorized access, hacking, and cybercrime would get you 1 mark, and then protecting individuals and organizations from the misuse of computer systems.
Today's video is about licensing. So software or applications have got licenses, and these are kind of the rules that you need to follow to make sure that they are being used properly or modified and shared properly. So whoever created the software or application in the first place, they're the people who make the decision about what type of license it's going to have. The license will protect the rights of the software creator, but it also lets others use it legally, and it states how they should be using that software. Now, if somebody's gained access to a piece of software, it might be that they're using it at home, which would be for personal use. If a business or a school are using a piece of software, then there might be other rules that they need to follow to make sure that they are using it correctly. Some type of licenses allow people to actually change the software and modify it, while other licenses may have some restrictions on whether it could be copied or shared with other people. But if you don't have a license for your software, it could lead to legal action. So there's two main types of licenses that we're going to be talking about and we need to know about for our exam, which is open source software and proprietary software. So we're going to start with open source software, which is software that is usually free to download and the source code is freely available. Now, what we mean by that is that you can modify and change that software to your liking. Part of the license being an open license means that you are allowed to do that. Now, what's really nice about open source software is that it's very community driven. So lots of people will download it because it's free to use, saves them a bit of money. But then anything they find out about the software or learn about it or any changes that they make, part of the license is that they will share that information and discuss it, which means the community are the ones driving that software further, updating it and fixing it as it's going along to make improvements along the way. So we also need to be able to talk about the advantages and disadvantages of the two types of licenses that we're going to discuss today. So let's have a look at the advantages of open source software. So as I said earlier, there's no cost usually, which is a big advantage that you don't need to pay for the software. And also you don't need to pay to be able to modify it. So if you needed to use that as a basis and then modify it to your liking, then you're allowed to do that. It generally has lots of security benefits as well because the different developers that are using it will find fixes and develop it further and fix any vulnerabilities. And as I mentioned, you can adapt it for your specific needs. So if you work for a company and you need to make an adjustment to fit the needs of the business, then you're allowed to under that license. Now, there are some disadvantages to open source software. The first one is that it generally lacks technical support. Because it's not a paid for piece of software, it's mainly relying on the community to be able to push it further, support it. So there's not going to be somebody that you can call to make fixes, which sometimes if you're the first to come across an issue, there might not be the answer to what it is that you're looking for. And on a similar strand to that, if it needs some sort of fix or a patch, you're relying on the community to be able to create that patch and then download it. And usually, because it's open source software, it's not as user-friendly as paid for software. So to begin with, there can be quite a steep learning curve with open source software. Okay, the other type of license we're going to have a look at is proprietary software. So this is one that's owned by a company and you've not got access to the source code. Sometimes it's referred to as an off-the-shelf product because when you buy it, that is what you end up with and get to keep. Now, if you're somebody who's quite happy to just accept software for what it is, that application, you don't want to make any changes or modify it, then it's usually fine. But as I said earlier, you've got no access to the source code. If you tried to access the source code, that would actually be illegal under this license. So when you purchase the software, you get a license to be able to use it. That is your legal copy of the software. And because it's proprietary software, it gets supported. There'll be regular updates for that piece of software. So for the advantages of proprietary software, because you get reliable support and updates regularly from the company, that's a huge advantage. Generally, there are more features on proprietary software and it's quite user-friendly as well because it's been developed with the majority in mind. And often you get a warranty or guarantee with it, so if it's not working or there's a problem with it, then you could get your money back. So for disadvantages of proprietary software, it can actually be quite expensive to purchase in the first place. Even though it's a good thing that it comes from the company, sometimes you can be waiting for that company to come up with any fixes. And as a big disadvantage compared to open source, you've not got the ability to modify or customize the software. So if it's not exactly what you're after, then there's no changes that you're allowed to make to that. Okay, let's have a look at a couple of questions on this topic. So question 1, give one benefit and one drawback of using open source software. And question 2, explain 2 advantages of using proprietary software for a business.
Okay, let's go through the answers then. So give one benefit and one drawback of using open source software. So as a benefit, it's usually free to use, which reduces costs. And as a drawback, it may have less support or documentation compared to commercial software. And question 2, explain 2 advantages of using proprietary software for a business. So advantage 1, it usually comes with professional support and regular updates, so that would be 1 mark. The software is working optimally at all times, so that would get you 2 marks. Then for your next 2, it has been thoroughly tested, that's 1 mark. So it's often more reliable and secure for business use, that would be your other mark, to get all 4 marks. And today we're going to be looking at ethical issues. So ethics means the rules of what's right and wrong. This is a very opinionated topic, but sometimes some of the bigger things that you can talk about come from cultural beliefs, religious beliefs, and general people's own thought on a matter. So this topic is always based around technology and the ethics of using technology. And it's about how we believe it to be right or wrong in using technology in a certain way. Now, this is not an exhaustive list. You could be asked anything about this topic, absolutely anything. So you've got to be able to just come up with reasons around it. But generally, with a bit of common sense, it's quite easy to come up with different things to talk about in it. And as you'll see in a moment on the next slide, is that you are always given some things to sort of base your answer around. You've just got to then be able to apply it. Here are some topics that are quite common with technology and could often be asked about in your exam. So cyberbullying and online messages is a big one. Privacy issues is another one that keeps going back to, and exposure to content, so what people are able to access and see when they're using the internet, for example. Other things that are common on an exam but are not necessarily a bad thing is about technology being a tool for learning, how it can be used in education and employment, and it's very common that technology is used for meeting other people nowadays. Now, I'm able to share these with you because these are from quite old past papers now. You may have even seen these yourselves already. But these are 2 previous questions on this topic. Each of these were worth 8 marks. And if you think roughly every 7 marks is another grade on your exam, this is a huge one. It's an extended writing task, this. So let's have a look at these 2. This first question says, the use of digital technology in medicine is constantly evolving. Discuss the impact of digital technology on medicine, including diagnosing patients, treating patients, and storage of records. So what you've noticed straight away there is they've given you the 3 bullet points that they want you to focus your answer on. It doesn't mean that you wouldn't get marks if you wrote about something different that you thought was very relevant, but it's just so easy to stick to these 3 bullet points. And for the examiner, they will be given a mark scheme that are based on those bullet points. So it's always wise to stick to the bullet points that you're given in your exam. Another example question, and I've shared these with you so that you can have a little go at these questions if you wanted to. Social networking websites use AI to monitor posts from users. AI is a massive topic at the moment. I think it's very likely it could be on this year's exam, but it is a complete guess. So discuss the positive and negative uses of AI by social networking websites, including legal issues, ethical issues, privacy issues. 3 huge bullet points that we keep coming back to in this topic. Looking at that first question with the impact of digital technology on medicine, let's have a look at the mark scheme of that so we can see what we're looking for with these topics. Now, we're only going to look at the top mark scheme because obviously we're aiming for top marks on these exams. So the candidate demonstrates thorough knowledge and understanding of a wide range of considerations in relation to the question. The material is generally accurate and detailed. So as long as you're sticking to those bullet points, you are talking about the right things. So I wouldn't recommend deviating away from the bullet points unless you are 100% confident that it is a solid answer. The candidate is able to apply their knowledge and understanding directly and consistently to the context provided. So we were given a little scenario at the beginning of this question talking about how medicine is evolving. So you need to be able to talk about that in your answer. It shows that you've read the question. Evidence and examples will be explicitly relevant to the explanation. So if you're waffling on for ages about something that's not even relevant, then you're wasting your time. Now, there was a command word at the beginning of this question. It was discuss. Now, when you see the word discuss, you need to be able to weigh up both sides of the argument. If you're arguing totally for something and never against, or vice versa, you won't fit into this top category. It is one of the most important things that will get you your top marks in these kind of answers. Now, this is how I think you should approach one of these questions. At the back of your exam paper, there is extra additional pages. Now, these don't have to be marked. You can use these to just jot your ideas down, and it's especially important when you're going to start a huge answer like one of these. The best way to do it is get the main topic as a spider diagram in the middle. The 3 bullet points that it provided to you, you can then write around your spider diagram. And then all you'd need to do is come up with a couple of points about each of those that they've given you. So that's what you're going to base your answer on. So for this question about the technology in medicine, for diagnosing patients, I went for, you could search records faster, it's more accurate, but it may miss symptoms or suggest incorrect results. So I've got things there for both sides of the argument. I could get some marks for saying that it's really fast to search records, which would save people time. But then I could also discuss the opposite of why it's not good by saying it may miss symptoms or suggest incorrect results. So this is already a solid part of my answer. However, that's only talking about the diagnosing patients part of it. So then I would move on to the next one, which is the storage of records. Overall, you would then have a conclusion to talk about why you think technology is either good or bad for the evolution of medicine. So if you nail all of these points and you've talked about the 3 bullet points, you've given an argument for and against with a conclusion, you've got the perfect answer and you've officially gone up an entire grade on that paper. So I've come up with a question for you to give it a go. I think you should pause the video and write down an extended answer like we discussed. Focus on the bullet points, jot down your ideas first as a little spider diagram. It'll be really good practice for the real thing. So the question is, discuss the ethical and legal concerns of AI replacing human jobs, including job displacement, legal regulations, and the economic impact. If you think on your exam you should be aiming for 1 mark per minute, then to write your answer, it should take roughly 8 minutes. To jot down your ideas for it, give yourself another 3 or 4 minutes. So what I've tried to do for the answers for this then, obviously you could have written about anything, so this is not an exhaustive list, but I want to go through some of the things that you could have written about if you couldn't really come up with any ideas on this one. So for the first one, for job displacement, you could have written about how AI automates jobs, reducing employment opportunities in certain industries. There's some ethical concerns over mass unemployment and economic inequality. It may affect low-skilled workers, increasing social divisions. And AI chatbots replacing customer service workers might reduce cashier jobs. But you could argue any of them for or against those points. So for example, the AI chatbot might get somebody faster customer service if there's not enough people that they can employ. It might get them an answer to what they need over the phone without even needing to speak to a human. Okay, so for the next one, legal regulations. So there's a debate over whether government should regulate AI in workplaces. As a possible solution, you could have AI taxation, or there could be employment laws that are protecting different workers. So the next bullet point was on economic impact. So AI increases efficiency, productivity, and lowers business costs. That's a definite argument for. There's potential to create new jobs in AI development and robotics. So lots of programming jobs that are going to become available to develop AI further. So as final points that you could have included your answer, so some ethical considerations. So should AI be limited if it improves efficiency but harms employment? Some people could argue that AI should assist humans rather than replace them. And finally, businesses prioritizing profit over ethical concerns about worker displacement. Now, as I said earlier, all of these are just ideas that you could have written about. It's not an overall list, but generally, as long as you're talking about the topic and those bullet points, you can almost guarantee that you've written enough for that point and you've got yourself some marks in that one. Today, we're going to be looking at environmental issues. Now, specifically for your exam, we need to talk about how technology can have an impact on the environment. Now, this isn't an exhaustive list, but these are the main topics that seem to keep coming up about environmental issues. So we've got climate change, pollution, and habitats. Now, one of the most common mistakes that people make is always think that everything that affects the environment to do with technology is a bad thing. There's actually loads of positives that you can talk about, and we're going to have a look at a few of them so that you can talk about it in your exam. So the first big positive of technology on the environment is being able to work remotely. So this was huge during COVID, especially when people were using things like Teams
Teams and Zoom to be able to communicate, teach lessons, and still have business meetings. It also meant that people didn't have to drive places as much, which means there's less cars on the road, which means there are less CO2 emissions in the air affecting the atmosphere. Another huge positive is paperless communication. So we communicate via email, which is a lot faster to actually get to where it's going, but also it means there's less cars on the road, which is going to be delivering letters. We also use things like ebooks and digital documents, which is having a big positive impact on the environment because we're not chopping down as many trees to produce these documents. A final positive of technology on the environment is smart technology. So most people in their homes now have a smart meter, which is making people more aware about the energy that they're using in their homes. As a result, people are using less energy, which is having a better impact on the environment. So we do need to understand that technology is also having a negative impact on the environment. What's important for this topic as well, though, is that for each of these, you need to try and come up with a possible solution to how you would counteract that negative impact on the environment. So the first one we're going to talk about is climate change. So to actually manufacture digital devices, it uses a lot of energy. Now to produce that energy, it comes from fossil fuels, which are releasing greenhouse gases like CO2 into the atmosphere. There's also a huge increase on people using streaming services like Netflix and Now TV. This is adding to the carbon footprint of digital technology. A potential solution to this might be where we get our energy from. Using green energy, solar powered energy, and so on might have a better impact on the environment. We are still going to be needing to manufacture digital devices. We just need to do it in a cleaner way. The next big topic that we need to have a look at is pollution. So toxic chemicals are used in the production of digital devices. And as it's being produced, if it's not being disposed of properly, lead and mercury can actually have a really harmful impact on the environment. Most of it will end up in landfill, and in developing countries especially, this can have a massive impact on the soil and the water in the environment. Something else having a huge impact on this is the fact that huge companies like Samsung and Apple have got a lot of pressure on them from the public to be producing new technology every single year or two. As a result of this, people are replacing their phones all the time, which means that their old phones aren't being disposed of properly and they're not being recycled, so it ends up in landfill. So as a potential solution to this, people should have maybe a donation scheme where they can pass phones on to other people who might not have one. There's a better way to recycle phones and digital technology to help reduce how much impact it's having on the environment when it's ending up in landfill. The final topic we're going to talk about is the destruction of habitats. Digital devices contain materials such as lithium, cobalt, and other rare earth metals. These get used in things like batteries and circuit boards. To actually source these materials, it means there's going to be deforestation and the destruction of natural habitats. This often occurs in countries where there's not very good environmental protection, and it has a massive impact on wildlife and the communities. As a possible solution to this, government and leaders need to do a better job of governing where these things take place, how often they take place, and by doing it in a cleaner way to protect the environment. So I've got a question on this topic for you to practice. A company plans to replace all employees' desktop computers with brand new laptops every 2 years to ensure high performance and security. Discuss the environmental impact this decision could have. Notice that this one is worth 4 marks, so you're going to need to come up with 2 things and a reason why it's having an impact. Okay, let's have a look at the answers then. So the question was, a company plans to replace all employees' desktop computers with brand new laptops every 2 years to ensure high performance and security. Discuss the environmental impacts this decision could have. So you could have put something like increased e-waste, that would get you 1 mark. Frequently replacing devices creates more electronic waste, which may not be recycled properly. That would get you a 2nd mark. You could have also put pollution from disposal. That would be 3 marks. You could then explain devices contain harmful chemicals which can pollute the environment if dumped in landfill. That'll get you all 4 marks. And that's it for this video. I'll see you next time.